send this into the table. So we're taking care of.
Oh, that's right.
Taking care of what he's getting for those functions that are built in.
No,
Are you ready, Mark? Are you there?
Yes, I am, and I can hear you guys clearly now.
Take it away.
all right. Well, it's okay. So this is totally separate topic from yesterday and about half as long a presentation, so we should get through this fairly efficiently. This particular item was filed under agenda item 3.3, and it will correspond to paper 12 in your reading material for the meeting. This analysis is a specific response to a request that the commissioners made at AM095, which was actually a follow-up to two informational papers that were produced late last year looking at the effect of discard mortality in non-target or non-directed fisheries, also called bycatch, on the projections for 2019, 2020, and 2021. That was info paper 8 and also info paper 7 provided that information. This was kind of a last-minute request that was made just before the annual meeting. Those papers are both available on the web if you want to get access to those. This topic of bycatch and what are the effects of bycatch on directed fishery yield that could be available is one, as you'll see in a minute. I'll provide some background, is one that's been a focus of the commission for decades, 30 years or more, and many analyses similar to this. I guess the important delineation here is that this request really represents some fairly targeted informational request for use in management discussions. It is not intended to be a broadly comprehensive scientific analysis. It's really a very specific question that the commissioners asked with regard to the historical time series. This particular paper also differs from the two informational papers from AM095, importantly in that it is a retrospective look at the historical effects rather than a prospective look at projected effects. And the only real technical implication there is that it's much more challenging to get a variance when I'm working in the historical time series than when I'm doing the projection. So in the projection, I could generate a variance for everything quite easily because this is just alternate catch streams in the projection. In this case, I'm having to actually fix the parameters and just recalculate values of the time series without actually getting a Hessian around that, because I have to keep the parameters fixed because this is the data that actually creates those parameters. So as background, there are, in the literature, of which there's a considerable amount, many of the papers discuss lost yield. So they're all couched in, well, if this much was taken in non-directed fisheries, there was this much lost yield, and this is the lost yield rate. Maybe because I'm an eternal optimist, I have turned this terminology around in this paper to talk about yield gain, because I think it's maybe more productive to think of it in terms of the potential for yield gain rather than yield lost. It's rather than having your pocket picked, it's extra something in your wallet. So, what's that?
Potential yield gain.
Yeah. So this whole analysis is really just trading sources of mortality. It's taking one source out and putting another source back in and then balancing the books. And this, because I've done this based on SPR, this is really the fisheries footprint. So this links to this concept that's now 4 years old, 5 years old, maybe even, of the relative contribution to the SPR of various fisheries. And although I've done this numerically here, it is exactly analogous to the concept of fisheries footprint and balancing the or evaluating the relative contribution to the SPR of different sources of mortality. Importantly, and this is something that I think has been somewhat missed in a lot of the historical analysis, is that the potential yield gain depends on a lot of things that change over time. It depends on growth, it depends on mortality, selectivity of each of the components. It depends on the discard mortality rates that are being applied. It depends on how hard you're fishing the stock. And this is the fundamental one that many of the historical analyses miss, which is that if you're fishing the stock very hard, the trade-off is different than when you're fishing it very lightly, and that's because they're competing simultaneous sources of mortality. Just like we can't take F and M in our stock assessment equations and treat them completely independently because they're simultaneously operating. Some of the fish that we would have caught died anyway from natural mortality. And so you can't just take one in isolation and ignore the rest. Finally, it also depends on the age structure of the population. So if we have selectivity is going to be interacting with the age structure of the population. You can imagine a case where you have a huge number of recruits coming into the stock. Taking a small number of pounds out of a huge amount of recruits may actually be less, may have a smaller influence ultimately on the SPR than taking the same amount of pounds out of a very small spawning biomass. And we'll actually see an example of that in the time series. So there are a variety of previous studies that are referenced in the introduction to the document. I tried to pick the ones that all boiled this down to a particular rate, noting that what they call this rate does differ in some of these papers, but it is all, in a general sense, comparable, although many of these values are specific to a particular year. In fact, the first study, Adlerstein, from 93 and 94, those estimates, and there's a range of estimates in there, were very specific. They were gear and even season specific, so it was based on monthly observations in a particular sector of non-directed fishing. And so that's why we see the greatest range there. But you can see that the range across the rest of these studies is essentially between around 1.1 and around 1.7, with some variety across those estimates. And some of that variety is due to the conditions, some is due to the way in which the analysis was produced. But this was my best attempt to put this all into context. You'll note that the last paper, or the last two papers there, the last row in this table, are the two info papers that I produced, which suggested that over the projected years 2019 to 21, based on last year's assessment, that this potential gain rate was in the range of 1.25 to 1.29.
Sorry, Ian, very quickly, for clarification, but you only applied this from the current state onwards, right? So you're looking at, not like some of those other ones where you sort of projected it back and said, oh, you know, if we had removed it in 10, we sort of phased this in kind of thing. So it's just that last, so is it directly analogous to what Jim was trying to get at in relation to the management plot?
No, it is not a replay of history. It is a sequential analysis of each year at a time, looking at the trade-off in that year. But it doesn't replay the whole time series as if different choices had been made.
So Jim was asking for this effect of a fishery,
right,
in the final year for the SSS, for the biomass.
This is not that.
Okay.
This is not that analysis. So the methods, we use two different methods to answer this question. The first one, the primary results, are based on just the numerical evaluation using the preliminary 2019 ensemble and going back, and I'll step through the iterative method that we used, going back and doing each year at a time to evaluate what was the direct trade-off between discard mortality and non-directed fisheries and the directed fishery, potential directed fishery yield gain in that year. In addition, because Pierre and Alan had already spun up this equilibrium model for reference point evaluation, we were able to do a second comparison, which was slightly different, which was just to look at a generic case in equilibrium where we had fishery and discard mortality and non-directed fishery selectivity roughly parameterized from the stock assessment model from 2018, look at scaling the mortality between those two fisheries and see how much the yield at a specific SPR changed. So I'll talk to that a little bit later on. So it just gives us another look that's not year specific, or maybe is a little more year specific to 2018, but is not dependent on the age structure in the population, and assumes the SPR target of or reference level of F46 rather than the SPR that was actually realized in a particular year of the time series. So, two slides to talk you through how this iterative approach worked in the ensemble. The first was to set all the parameters to the maximum likelihood estimates and then turn off estimation. By turn off estimation, I mean I can turn the model over and recalculate quantities, but all the parameter values stay exactly the same. I can't generate a Hessian when I do that though. But what it does mean is that I can change the catch in any particular year and keep all of the parameters the same without having that be affected by the catch that was different in a particular year. Then sequentially, 1 year at a time, I set the discard mortality in the non-directed fisheries to 0, noting that the commissioners asked for this analysis to start in 1991. The short time series models don't start till 1992, so they're going to get 1992 onward because that's what's available. Then with the discard mortality and non-directed fisheries set to 0, then I increase the directed fishery via some scalar, let's call that alpha, and start that with a value of 1, and then as you'll see, iterate forward, recalculate the time series using the MLEs, not the re-estimated parameter values, and then generate the estimates of SPR. Now I don't have a variance for that SPR because I can't generate the Hessian. So what I did was to use the original variance estimates for each model for the SPR in that year in order to create the ensemble median SPR and then iteratively find where that will match. So based on the adjusted discard mortality in non-directed fisheries, now 0, and the directed fishery mortality, first iteration exactly what it was before, you get a new SPR and a new ensemble SPR. Then compare that median to the original SPR for that year and repeat that iteration, adjusting alpha until the original and the ensemble SPRs match. So basically you're solving for the directed fishery catch that generates the exact same SPR you had before you took the discard mortality and non-directed fisheries out. Then calculate the difference between the commercial mortality before and after those iterations, and that's the yield gain. So how much have you gained by taking the discard mortality and non-directed fisheries out and allocating it all back to the directed fishery? Then dividing that by so that's the yield gain in pounds, and then to get a rate, you then divide it by the amount of discard mortality you took out. Now it's pounds to pounds, and now it's a rate because the units cancel. So the second piece, and one of the things they were interested in the original analysis as well, was the spatial distribution of that yield gain. And to do this, I followed the two concepts that are implemented in the IPHC's current interim management strategy, which is that all of the 026 discard mortality and non-directed fisheries gets transferred directly to the directed fishery within the area that it occurs. And that's exactly how the current harvest strategy calculations work for the projections every year. The second component is that the U26 discard mortality in non-directed fisheries gets allocated by area in proportion to the O. In proportion, yes. So sorry, let me say that again. The directed fishery mortality after we've added the 026 in has a distribution across the areas. That gets scaled without changing the proportions to account for the U26. So if there's, to get back to the SPR, all of those pieces come up in concert, which makes the assumption, the implicit assumption, importantly, that the distribution of those U26 fish would match what we see in the rest of the stock. And that's that's exactly the same assumption that's made in the current management procedure that's applied. So the results of this, there are tables in here showing you the magnitude of discard mortality and non-directed fisheries. Table 1 shows the historical time series. I've got a figure in there as well. Discard mortality in non-directed fisheries has a huge range. In 1992, it's over 20 million pounds, and when you get to 2018, it's all the way down to 6 million pounds. It's more or less a one-way trip, as we'll see in the figure. But nonetheless, the absolute magnitude of discard mortality in non-directed fisheries has changed dramatically over the time series. So there is that time series. The blue bars are the discard mortality in non-directed fisheries. You see 1992 was that peak above 20 million pounds. It's generally been a one-way trip of decreasing discard mortality on non-directed fisheries. And on the secondary axis here, I've plotted the year-specific commercial gain rate. And you note a couple things. One is this early time period when the gain rate is actually less than 100%. And so what's happening here is this is a time period with a large number of recruits coming in and a relatively small biomass. So 1 pound of fish being removed as discard mortality in non-directed fisheries has a relatively small effect on the SPR, where 1 pound of fish coming out of the spawning biomass through the directed fishery has a fairly large effect on the SPR. And so I think that's useful to note, that this is not always a one-sided calculation. It's not always a positive gain rate. We'll note that over the time series, the average was 115%, and the range was 86 from down here in the early 90s up to 139% here in the mid 2000s.
Just on the technique, one thing that came up, I wasn't clear on, so the way you do it, it seems like there would be a lag effect on spawning biomass. So it's not like tuning it up to get the right SPR in that year by deleting a fishery that might be young fish is going to have the same effect. Just a little.
Well, imagine in equilibrium,
This.
you'd have exactly the same spawning biomass that would result from that SPR. What this is doing is it's taking the age composition and the selectivity and the interaction of that in a particular year and balancing the SPR. This is the IPHC's current interim management procedure, which is a constant SPR.
Right.
So we're doing exactly this in our annual calculations. You're right in that in a particular set of years, the spawning biomass is going to fluctuate depending on how you achieve that SPR. But over the long term, you're going to end up with the same effect on the spawning potential.
I guess the important point on this figure, I think, is a good one, is how variable.
Yeah. And this range encompasses most of those historical studies, the range that we saw across most of those historical studies.
And I think this might be the same as Jim's question, but so you could essentially just pick out a year and do this analysis on just the 1 year, any given year, because you're not sort of connecting them to one another.
That's exactly how I did it, 1 year at a time, completely independently
Yeah.
from all the other years. So it is definitely not a replay of the whole time series. So you're not seeing, in 2006, you're not seeing the effect of having switched from discard mortality and non-directed fisheries to directed fisheries 5 years earlier.
Yeah, it's
Because
not
that's not the way
it's not
it's
the
done.
I think that's where the
downstream effect.
negative comes in.
Yeah.
It's actually the fact that you get that benefit in a few years' time as opposed to getting it in that year.
Except if you stuck to a constant SPR, you wouldn't. You would be fishing the stock at the same SPR rate over this whole time period, at the SPR that was actually fished. You would get a different time series for sure,
Yeah.
but it wouldn't necessarily be higher or lower. I don't think you could predict. On average, over the long term, it would be the same.
Well, it's probably more an influence of the 87 year class.
And the surrounding year classes. You have several big year classes that are prominent in the age composition here.
You know, and that's the awkward thing with it. I mean, there's not really a selection pattern to a bycatch fishery. It's just whatever fish are there get caught, you know.
But the point is, if you have a time period with a huge number of recruits coming in,
You'll get a
the
different.
same number of pounds of those small fish is having a smaller effect on the stock, which is fairly intuitive, but not always described in these kinds of analyses. So the distribution then, this is the distribution, average distribution over the whole time series in the top row of the non-directed fishery discard mortality. And then this is the distribution of the yield gain. This is the combination of two tables that are in the document. But what you see is that these don't line up exactly. And this is because the yield gain is distributed based on the proportion of O26. It's based on the distribution of the directed fishery itself, assuming that those fish are going to be redistributing, essentially, that mortality is going to be redistributed across the IPHC regulatory areas in proportion to the biomass or the yield in that particular year. And I think this is an important point, which is that we see the largest amount of non-directed fishery discard mortality in area 4C, D, and E, but the largest yield gain is in 3A. And that's because we have a lot of recruits in 4C, D, and E, but we have most of the subsequent biomass in 3A. And that's why these two distributions differ. And this is, in fact, one of the main points that the commissioners are interested in is how do these effects play out across the rest of the stock? Now, this is very, very explicitly not modeling migration. So this is not looking at a model that includes downstream effects, which may or may not create a different scenario to this. What this assumes is that the migration pathways that generated the current biomass distribution would be similar to those under any fishing scenario. And we know that there's directional movement. So it could be that those migration patterns would be affected by how the resource is allocated among fisheries. So that is clearly not this analysis, and that's stated pretty clearly in the document. The second approach that we applied, the equilibrium model, as I mentioned, was parameterized after the 2018 stock assessment. It unlike the historical analysis, it just holds SPR constant at a value of the reference level of F46, and it just compares the yield across a range of allocation scenarios between a directed fishery and a non-directed fishery. Importantly, it doesn't include any discard mortality for the directed commercial fishery. So in the historical analysis, when we give fish to the directed fishery, some of those are caught, discarded, and lost to the system. In this case, there is no discard mortality, and so we would expect these ratios perhaps to be slightly higher because we're basically it's all going into the landings. And so they are slightly higher, although they're still pretty close to the same scale that we saw before. So what this table shows you, we did 4 scenarios, and this is the ratio of F in the directed fishery to the ratio of F in the non-directed fisheries, and the relative yield that's produced at SPR equals 46. And you can see that as you shift the F from the directed fishery to the non-directed fishery, you get a loss of yield to hold the same SPR. And if you do the algebra and turn that around into a comparable potential gain rate, as we did in the other analysis, these are the values. So you get a gain rate at 20% non-directed fishing, you get a gain rate of 121% up to 144% when you've moved all the way to 100% non-directed fishing. Again, holding the SPR constant at F46.
Currently, the non-directed is what percent?
It is roughly between 15 and 20% of the catch. So assuming catch is in the ballpark of F, we're looking at something in the range of 121%. So this was just another way, since we had the tools already available, we thought this would be a useful comparison just to see. This is, again, not a historical analysis. It's a look just at.
Just another clarification in the document. I'm pretty sure I understood. I think you started out as multipliers and then turned it to percentage. Anyway, it's 121% means 21% more. It's not like 120. It's not plus 121%.
Correct. Correct. If you have a pound of non-directed fishing, you get 1.21 pounds back. I could easily I could easily turn those back into 1.21. Yeah, you're right.
Everybody does it different.
You're right.
Over this
Yeah, that could be.
Yep. I thought it was easier to think about as
It's not 121%.
It's not plus 121%. It's 121%.
Right.
The rate is 121%.
I thought I got that the whole time, but I
yes.
just wanted to make sure.
Yeah, good clarification.
Yeah, I mean, I guess if you say gain over there, you could just put 21%.
Yeah, that's my point.
Well, it's a rate. I think I would have to put a plus sign in front of it.
Yeah.
If I put a plus sign in front of the 121, then it would be 121% you'd get.
Right, and that was
Right,
You
yeah.
get 2.1 pounds back, but I think without the plus, it's, well, I don't know. I could certainly change those to different units. Almost all of the historical studies did not subtract the 1. So I was trying to stay in the same
Right.
scale. They're all 1.2 or 1.3 or 1.4.
1.4 times, but yeah, I just,
Right.
this would be a bad thing to have a.
Because this is a pound for pound. In the past, it's been described as a pound for pound. And, you know, in the salmon world, there's this concept of adult equivalence. And I think in that case as well, it depends on all these inputs. And so it's more stable there because your sources of mortality are not simultaneous. Usually you have something going on in the ocean and then you have ultimately the fishery that's occurring. But in our case, those two things are simultaneous. And so I don't think we should expect to see the gain rate be something that's just a static quantity that's robust to all these inputs and doesn't change. It's in fact quite dependent on all these other inputs.
Can you just explain those first two columns again? So 100% and 0% gives you no gain. So that means status quo, right?
So no, this is, because this is an equilibrium model, we're just looking at how much yield you get at a constant SPR. And so at a constant SPR, you get the most yield if you put all of the fishing mortality into the directed fishery. And then as you start to shift the F between the fisheries, you get less and less yield. And so we calculate the gain rate based on that. So the gain rate is just this repackaged into the same units as the other analysis.
Yeah, just for some reason, it seems I would be looking at trying to achieve the best gain rate.
Right, so if you put all your catch in the directed fishery, you get the most yield.
Yes, but it's 100% non-directed is what it says there. That's what's kind of...
Well, so you don't get any gain rate if you didn't have anything to take away. If you didn't have any non-directed fishing, then there is no gain rate because you already gained it, right?
Just think of it, fancy yield per recruit.
Yeah, all right.
They're not even very fancy. It's really pretty simple. So my main points here are there is no constant gain rate. It depends on the conditions that are going on at the time. And I want to be very clear to the commissioners that this isn't something that they can just say, oh, the exchange rate is 1.2 to 1, and that's what we'll use from here on out every time we have to convert pounds to pounds in negotiations, because it depends. As we've had already discussed now, it's not a replay of history. This is a sequential analysis in each year. And if you were to imagine that we went back to 1992 and didn't have any discard mortality and non-directed fisheries for the whole time series, we would get a different answer here.
It's not even sequential. It's just an analysis of each individual year, right?
Yeah, independent would be a better word there. It's a sequential independent analysis. I happened to do them in order, but I didn't have to. Wouldn't have mattered
Right.
if I'd done 2017 first and 1994 second. This, as I also noted, this assumes no distributional feedback beyond the stock distribution patterns actually observed. So downstream effects caused by the interaction of ontogenetic movement and spatially specific harvest is not something that's included in this analysis. You can't do that without an explicitly spatial model. It's something that we will start to see the effects of downstream effects in the MSE operating model, but we're not going to see them in this analysis. And finally, I think that is sort of the point, which is that if this is part of a management strategy, if this is feeding into how they're going to decide how to treat these allocations, then it's really something that should be looked at as part of the management strategy and evaluated simultaneously with the choice of SPR target and control rule and everything else. What's interesting about the situation right now is that the Commission and the MSAB have specifically decided they do not want to consider discard mortality and non-directed fisheries explicitly as part of their management procedure. Even though on the assessment side, we're clearly having this discussion as part of the management procedure, it's been explicitly excluded from the MSE process. It's included only as a source of variability, not as part of the management procedure. So again, we have another somewhat inconsistency between their management decision-making process that's occurring and the one that they are trying to evaluate through the MSE.
You've been told not to evaluate it.
It's explicitly told no. Yes.
There's some context behind that though, isn't there? Like, am I bring this or assigning this to a different issue that like it was decided upon as, grouping things as things that the commissioners, the IPHC have control over and things that they don't have control over. It was part of that discussion, right?
Yep.
So, yeah, so just, I think that's some important context too.
Sure. But it is, in the context of using this information to make management decisions, it is interesting that we've got this dichotomy between what they're doing, which is using this information to discuss essentially allocation, and yet not including that as part of their management strategy evaluation. I think that's a pretty glaring inconsistency. But you're right, it does, the historical basis is that essentially the MSAB didn't want to try to tackle that early on because they felt like there wasn't enough, there weren't specific control points. And so they just wanted to put that into the noise. But there were 3 or 4 meetings of discussion before they reached that conclusion.
True, yeah. I'd have to look back at my notes, but.
So the,
Can I just ask a
Yeah.
question about that? Maybe this should be directed in the MSE section, but so you're saying that they're not allowed to evaluate this as part of the management procedure, but do they simulate the effect of this in the operating model in the simulations?
so, but it's just treated as noise. It's just random variability. The variation in, well, you can speak to it, I'm sorry.
We can talk about it in that.
And we talked about it a year or so ago in the SRB.
It seems like it also, not to prolong this discussion, but it seems like it also went into sort of like the parking lot of future scenarios that could be
Definitely.
simulated, so I don't,
After this MSE is completed,
right,
when we begin the next round, we'll see what the appetite is to investigate this as part of a management procedure.
So this is really an informational piece for you, noting that the commission asked this to come through the SRB for any clarification or additions or changes that would need to be made. This will be presented after responding to any suggestions you might have. This would be presented to the commissioners at the interim meeting, and depending on whether they're interested, again, at the annual meeting this year. This is, I think we're on a better process this year, which is that they asked for this ahead of the SRB meeting rather than over the Christmas break with a couple of weeks to go just to the annual meeting.
Yeah.
So if you think there are things like if I should change the reporting to just 21% as opposed to 121%, or maybe if there are corrections in the document that would make that more explicit, you know, any suggestions you have would be very welcome at this point. I think that's all I had on it.
Just on that point, maybe just have a paragraph or a bullet saying what exactly the convention is and how to interpret it, so that's in front.
I think I might even put that all the way back on this, in this analysis, just have a little section at the bottom, 1 pound equals 1.2 pounds. And then note that we're using the same units later on.
There is some slightly confusing wordings, I think. Have a look at.
Sure.
That may just be my element. But what I don't get a sense of is how does the commission actually want to use this? Because some of the caveats you discussed is that they're in this actually say, well, it would be okay for this, but you couldn't use it for that. And I don't get that sense. And they wanted independence so that, or at least I get the impression this is really just pie in the sky in some way, shape or form, because you haven't got a control over that fishery. So I don't know what to say about it because I don't know how they want to use it. You know, what can you use it for and what you can't use it for.
Sorry, just to clarify, what do you mean by don't have control over the fishery?
Well, the non-directed fishery.
The US has control over the fishery.
Well, I can't see how you, without making a consideration of what other losses of yield they would have, you can just say, well, sorry, you're out of here. Right? So that's kind of how I interpret it, but there may be different elements to that. It's not under the control of the commission, is it?
it's under the control of the US who's a contracting party for the commission. So in theory, we review and agree to the catch sharing arrangements. And then the PSC limits are outside of that, but they are determined by the US in this case. So it's directly, the commission could make decisions on that if the parties agreed, noting that you have two contracting parties, 3 votes apiece. So yes, they could, and they're under discussions about including it into the TCUY. So it's there. It's not currently done that way, but it does have the ability to be done that way if both contracting parties agree.
Just so you know, maybe it's obvious, but nothing, all of these non-directed fisheries are not allowed to sell out of it.
Yeah.
It could be that this whole analysis is moot now, given the developments at the work meeting around dealing with U26 directed fishing mortality. There seems to be a tentative agreement on how to deal with this that may make this information.
I think the US said they were going to look at it.
Yeah, I don't know that it's a done deal, but assuming they move forward with what's been proposed at the moment, this isn't really going to be all that relevant, I don't think. But I'm sure glad I did it.
Just relevance-wise, I mean, how many commissioners do you think know that it's variable as much as it is?
I think that's kind of new information. I mean, I was actually surprised at how variable it turned out to be. And so I think that may be one of the highlights of this analysis, is to remind people that it isn't a static rate, and that it does depend on the current stock conditions and the current selectivity and growth patterns and mortality patterns. So maybe it's worth it just for that. And what?
Or just numbers at age.
Yeah, all of those things together, yeah.
And if you assume on top of that that there's some relationship between growth and SSB, as soon as you try to do this for a different SPR kind of value, you're going to have second order effects on top of that.
Absolutely.
And I guess from the SRB's point of view, do we think anything about seeing that and then seeing the equilibrium analysis? And somebody might, I mean, is there a communication disconnect because of the variability? I mean,
I see what you mean. Well, I guess, I think we would try to provide the appropriate caveats on the equilibrium result. That we were really just checking to see whether the central tendency was similar, basically a cross-check.
no, I'm not criticizing what you did.
But I think you're right. We need to be careful not to overemphasize the equilibrium result as a takeaway number, given the variability that we got from the actual time series.
So the equilibrium result will vary also depending on the weighted age, whatever you
Well, yeah, all those
use.
things are
2018 year,
right?
So it would still have variation.
So
I think your point about with the appropriate caveats, you can only determine the appropriate caveats if you know how they're going to use it, and that's where.
But that could be something that
You can the appropriate caveats. You only know once you can list all the caveats. Yes.
So that's something I think the SRB could note, that note the variability in the time series, and that although the equilibrium result provides a check on the analysis and another way to compare, it doesn't represent a specific outcome.
right. And I guess we might bring it up again with the MOC side of things. I don't know how much, because that variability, it's like you say, what do you have control over? You want to be able to note that weighted age is going to change, but we don't know how necessarily. All these other things that we talk about all the time, but this is another source of variability that's not that commonly introduced, I think.
Yep. So anything you could add to your report that would help to clarify that? Because if you have 2 or 3 things that you note in the report, they will be very, as you all know, the commissioners very carefully, word for word, will be reading your comments. So they'll likely be as important as anything I can say in the discussion or part of this paper.
In terms of, you've said that you've been working on this for, well, not you in specific, but the commission's been working at this for over 30 odd years, but it seems like it just keeps coming back. So is there something that either the commissioners can make a decision on, or that more information is needed in order to address whatever the question is that seems to make it keep coming back?
Well, I think noting that it's variable will help people, because I often get people who say, well, I looked at Hare and Williams and they got a different answer than Sullivan, and how come? Why every time we ask, we get a new answer?
Okay.
So maybe this will be somewhat helpful in that, just saying, look, every time you ask, you should expect to get a different answer because the conditions are going to be different. So maybe that's, maybe we've made a small step forward here in the story, although I think the trade-off, if this is essentially comes down to a tool with which to evaluate the implication of allocation decisions. And no matter what situation you're in, allocation decisions are going to be brought out of the closet every so often regardless. I mean, they never get solved. So maybe we shouldn't expect it not to ever get solved.
I think, yeah, I would agree with that. She was my office mate when she did this.
Sarah?
I remember when she was doing this, and it was because at that time the halibut stock was going down and they were pointing fingers at the bycatch.
And the bycatch was still pretty big then.
Yeah. So was the stock.
Okay, well, I took more time than I was supposed to,
But
thanks.
thank you, I appreciate it.
Let's see where we are. So we had a recap of halibut. We now had a break and then MSE.
Is there anything else you wanted to recap on from yesterday? Assessment wise?
We get to that.
We'll get another opportunity, I hope.
I
Sure.
think there's a time period tomorrow morning as well for another follow-up as needed.
I think this morning we only talked about something that's going to happen for June. I mean, so nothing so far
Sure.
immediate for this year that I've.
Do we want to have a loose coffee break or? Are we going to need a break?
Yeah, Alan's really slow on computers.
30 folders to go through. It takes me a little while.
I can't even read the screen.
So we're just going to take a quick, say 10-minute break, Mark?
Okey dokey. Talk to you then.
Hey, Alan, can you mute the microphone for us?
Pardon me?
Ristretto.
Ristretto.
Thanks, mate.
You back?
I just unmuted. Mark, are you there? Let's see if something's happening here. Hi, Mark, can you hear us?
Yes, I can. I was just coming back from my freezer with my ice packs to ice my knee.
Okay.
Freezer was thinking ice cream.
All right, well, hopefully this presentation makes you feel better, Mark.
Absolutely. Okay, and I'm going to mute now while I make all the noise, getting it set up.
All right, thanks. Okay, so we still have the same attendees, and I will begin. Okay, so this is agenda item number 7, and this single presentation is associated with actually 3 documents that were provided on the website. Document 09 is just a general overview of the MSE process and update on what we've been doing. And document 09 actually contains references to these other 2 documents as well. The other 2 documents, 10 and 11, both have revisions on them. So I think those revisions came out on September 10th, sometime around then. So please make sure you have those recent versions. We just wanted to update a few things and make a few corrections, very minor corrections. If you read the old documents, you still get the final picture still the same. So a little bit of outline here is a few things I want to go over today, and we're going to take a break at 12:30 for lunch. Is that correct? So we'll see how far we get. Ian had 40 slides yesterday. It took a little over 2 hours, and I also have about 40 slides. So we'll see what happens here. So talk about objectives, which will get us into the target biomass that we've been discussing with the commissioners for a while and mentioned last SRB. Distribution components of the management procedure. So how we're framing that and how we'll work with the MSAB on that. A brief update on the technical development, and then a look at the program of work and the timeline. So the goals, general objectives, just as a reminder, we're operating under these 2 goals right now: biological sustainability and optimizing directed fishing opportunities. Noticed in gray at the bottom, I have minimized discard mortality and minimized bycatch and mortality grayed out because those are not being explicitly considered at this point in the MSE. As Carrie mentioned earlier, that was a decision by the MSAB in that we didn't want to try to do, we didn't want to try to do too much at once, bite off a few little things, and we decided to, the way we've been phrasing it, the MSAB, take that what may be a management procedure, something that we can control, and instead put it into the box of something that we choose not to control at this point in time, and we're just simulating it under a random process in the operating model right now. And underneath these different goals, we have some general objectives, which will become more clear as I show you some tables. So I'll just leave it at that for now. So before I get into objectives, just to remind you once again, there's the 2 different components, major components of the management procedure that we've been talking about the last few years. And that's a scale component that's defining the coast-wide scale, the coast-wide fishing intensity. And that's what the MSE had been focused on up until basically the last annual meeting. We saw results of those in June. I updated you with the results that I presented at the annual meeting in June, at the June SRB this year. The other major component is the distribution component. And that is, once you have this coast-wide scale or a coast-wide TCUI, how do you distribute that or allocate that to the different regulatory areas? What's the process of doing that in the management procedure? So I'm going to talk about objectives now, and I'll begin by just reminding everybody some commission directives that have guided us since the annual meeting. And First of all, the commission endorsed the primary objectives that were presented at annual meeting 095, and that's basically the coast-wide objectives, which I'll review here shortly and indicate where any minor changes were made. The second directive was the development of a spawning biomass target. So we had a spawning biomass limit, but we did not have any sort of target, and we'll have some discussion about that coming up. So biological sustainability on the coast-wide level is, there's one objective under this, and that general objective is just keeping the spawning biomass above a limit to avoid critical stock sizes. This is really common. And in terms of defining this as a measurable objective, we've defined that limit as 20% of unfished spawning biomass. And we defined a tolerance of 5%. So any management procedure that does not meet this coast-wide biological sustainability objective will not be considered any further. In fact, none of the other objectives will actually be considered. And I just want to note, I believe I presented this at the June SRB, that we've updated this tolerance to 5% from 10%. At the annual meeting, we're operating under a 10% tolerance, but to match sort of international standards, Marine Stewardship Council, 5% just seemed more reasonable. And it doesn't change the interpretation of any of the results I've presented on the coast-wide MSE. This is a new one that was not used in the last analysis or evaluation. And this is maintain the spawning biomass around the level that optimizes fishing activities. The reason we phrased that general objective as that is the MSAB was very interested in two sort of sub-objectives or measurable objectives underneath that general objective. One of those objectives was to have a spawning biomass threshold where you maintain some spawning biomass above that threshold with some tolerance that's not necessarily 50%. So the second objective here is maintaining the spawning biomass above a target reference point. And to me, a target implies a 50% time being above, 50% of the time being below, which was actually an interesting discussion with the MSAB. They didn't see a target as that. Yeah, Sean.
I'm just curious about 2.1.
Yeah.
What the purpose of that is.
So that, yeah, the first one, 2.1A up there. Yeah, so are you saying this whole general objective?
Oh, sorry, not to, I mean 2.1A.
Okay, sorry. So the spawning biomass threshold, that is interesting. So first of all, the previous harvest policy or quasi-harvest policy was developed with the objective of maintaining the spawning biomass above 30%, at least 80% of the time. So that's something that stakeholders seem to have in their mind when thinking about developing harvest policies. That's something Clark and Hare came up with when they developed this. And their thought process on that was that it would keep the spawning biomass around MSY most of the time, around a biomass that would support MSY most of the time, being 80% of the time. So that was interesting. This objective was also developed in relation to the control rule, where the MSAB felt that they didn't want to be on the ramp, is what they're calling it. They didn't want to be below 30% because additional management action would be taken. It was seen as bad, maybe the perception of that was bad, and also it causes an increase in variability on the TCY. But as the SRB noted in June, that conflates the objective with the management procedure, which I totally get. As soon as you change your management procedure, do you change your objective, which is a little bit awkward. So this is something I want to discuss with the MSAB. Do you want to maintain this objective? Is this important to you? And if we maintain this objective, that we define actually a spawning biomass threshold here that is some fixed number that has some justification. It's not related to the management procedure or the operational control point. And I think
That would be 2.1B.
that would be 2.1B with a different defined tolerance. So that's the interesting thing here. If we're defining a target biomass, does that imply that the tolerance is 50% for a target? And that's my interpretation of a target is that most of the time you're around that target, you're fluctuating around that target. The MSAB has argued that, well, no, this is a target that you just want to be above more often than you're below. Semantics, right? I would like to have one objective here, see if we can get to that point.
Did you recommend that? Didn't we already recommend this, as you said?
You recommended not conflating the management procedure and the objective, but it didn't really go much further than that. The recommendation says you see the point of 2.1b, but 2.18 conflates it. So being maybe a little bit more specific in your recommendation maybe help.
I think also the last MSAD meeting was in May, so your last meeting was after that, and it hasn't met again in weeks.
Yes.
You know.
And that's true. So I haven't actually been able to discuss your recommendations with MSAB, and we will in October. One thing that did happen between June and now was we had an ad hoc working group meeting to discuss these objectives, but that was focused on distribution objective. So then related to spawning biomass target at the MSAB, and the MSAB actually made a request, which I'll remind you in a moment, but was to look at reference points, what appropriate target reference points may be, and to define a target objective based on some sort of reference point, whether that's MSY or MEY, maximum economic yield. So that's some things I'm going to have to discuss with the MSAB, and notice we don't actually have a number in there quite yet. And the MSAB is actually looking to the SRB for advice on this, where to provide advice to the MSAB on potential MSY and MEY proxy target reference points to fill in objective 2.1. So to help the SRB with that task, or that request from the MSAB anyways, Pierre and I did a analysis of dynamic reference points using Pacific halibut as a case study. And this was to investigate the variability in reference points, given changes in productivity and selectivity. How does that affect these reference points? As well as incorporate different types of uncertainty in the reference points, such as steepness, natural mortality, and other things like that. And then hopefully that will provide some basis for defining potentially an appropriate target reference point. We looked at reference points such as B0, MSY, RSB is relative spawning biomass that would meet MSY, and then the SPR that would result in MSY, or the harvest, the fishing intensity basically. And we used 3 different models to do this, or 3 different approaches. One was the equilibrium model that Ian mentioned in the bycatch analysis. That's why we had already developed that tool, and Ian thought it would be useful for that analysis. The second methodology is we did sort of a retrospective look at reference points using the 2018 assessment model. That was using all 4 of the individual models and calculating the reference points retrospectively over time, given the weighted age and the selectivity and other parameters estimated for that one specific year, looking back in time. And then the third approach was using the MSE operating model. So this is thinking more about projecting forward, and projecting forward with the variability in weighted age, the variability in allocation between sectors, the variability in recruitment. Well, actually, we looked at high and low recruitment regimes, but trying to integrate over that variability that could be potentially seen in the future. So the main sources of variability considered were a number of different things. We looked at how does the environmental regime, being it's affecting a high or a low R0, how does that affect these reference points? The weighted age, and we had either 3 scenarios, low, medium, or high, and then the operating model also did the random walk scenario, so it integrated over that. We looked at changes in selectivity, how that affects these reference points, and then steepness and natural mortality as well. And each of these different methods sort of has a unique view on the same outcome, or the same look at it. We'll talk about those in a moment. So the equilibrium model just basically was simple, assume two fleets, directed and non-directed discard mortality. There's a two-sex model, and it used a grid of different scenarios. And so that grid means it looked at very specific cases. So it looked at a low weighted age and a low recruitment, a low weighted age and a high recruitment, different steepness values, and natural mortalities, et cetera. The ensemble assessment approach, as I said, looked back in time. It used the weighted age in that current year and the regime in that current year that would indicate R0. And basically, it then fixed the projections at those observations, say a low recruitment and a low weighted age, and then projected into the future to calculate the different reference points, MSY, SPR, et cetera. So we're calling these dynamic equilibrium reference points, in that it's using that observation to then say, if the weighted age stayed exactly at this in perpetuity, this would be your reference point. And then finally, the MSE operating model used only the short and long coastwide models, because that's what the coastwide MSE was based upon, or that operating model. It calculated the reference points over a 50-year period after 100 years of simulation, so you can see how they change over time in this. But for summary of statistics, we used that last year in that 100-year simulation. It did the runs separately for low and high regimes, because we really wanted to look at that specifically, but sometimes weighted age was modeled as a random walk. Sometimes it was looked at under low, high, and medium scenarios as well. But selectivity was always allowed to change, and that was a function of weighted age with also some additional random component to it. So different sort of ways to incorporate uncertainty as well. And just to summarize the results for you, the B0 and the MSY, the actual maximum sustainable yield, were quite variable over time in all these models. So meaning they were variable depending on the observed weighted age and the recruitment regime, as you would expect. If the fish are bigger, you can get more yield. The relative concepts, being RSB, relative spawning biomass, and SPR, were much more consistent across time, and the regimes didn't have as much effect on those. So there's some figures in the document that actually show this, that show the flatter trajectories for RSB and SPR compared to B0 and MSY. So the resulting, given all these different sources of uncertainty, for relative spawning biomass that would achieve MSY for Pacific halibut, as we've modeled it, between about 20 and 30%. And that would be associated with an SPR of about 30 to 35%. Steepness had some effect on these results. That was probably one of the bigger ones. But again, we looked at steepness of 0.5, 7.5, and 0.9. And then the recruitment regime didn't have as much effect, and weighted age had a little bit of effect also. So that is basically summarizing this up, looking at the results. And then if we were to say, as other harvest strategy policies around the world have done, to make an approximation of what an MEY reference point may be, it's been reported in the past that it could be about 1.2 times the RSB for MSY. That would put MEY RSB reference point at about 36%. So that's sort of what we are, the results that we have. We would like to write a journal article with these results in it, and we have a little bit more future work to do on this, but this is what we have available for review today. A couple of things that will happen in the future. I will be presenting these results at a Pisces workshop that's associated with Pacific halibut. So that'll be really interesting. I think I'm after the keynote that morning, in fact. And then both Pierre and I are going to the next generation of stock assessment models, the Kaplan workshop in New Zealand, and Pierre will present this from the viewpoint as the calculation of dynamic reference points is an important concept to make sure the next generation of stock assessment models can do and include uncertainty in those calculations. We have a couple of research things that we want to tackle. We're trying to figure out how the stock recruit curve should be modeled in this equilibrium calculations depending on changes in productivity. I have a little bit in the document, and actually that was one thing we put in the revised document, was a discussion of that. We want to update the analyses with the 2019 assessment if we have time, and then write the journal article on that. So that's the dynamic reference points. That's one of the papers with that 11, I think paper 11. It was a fun analysis that we did. This, again, is results to be used to define a reference point. So I wanted to present here some results from the coastwide MSE and then put this into context of if we were to fill in that objective 2.1, what would it look like in terms of the MSE results that we've already been seen from last year? And so on this plot here, I have in the upper left, this is the sort of outcome SPR, or that actual SPR that would result from application of the entire management procedure. And so we have what you can see, 3 different control rules, a 40-20 in red, a 30-20 in light blue, and 25-10 in dark blue. And you see that the control rule just starts kicking in at higher fishing intensities. So even though you're inputting a 30% SPR into the management procedure, you're actually operating under about a 45% SPR because that fishing intensity is being reduced based on the control rule. The upper right plot shows the median average relative spawning biomass for those 3 different control rules and input SPRs. And it says that you're driving the stock lower with higher fishing intensities. The bottom 2 plots are the probability that the relative spawning biomass is less than 30%, a fixed threshold. And again, that's relating to that 2.1A objective of defining the threshold. And I would focus on the rightmost plot where the any is referring to the probability that the relative spawning biomass in any year of a 10-year period falls below 30%. So what I've done on this plot is indicated a few of those reference points defined in the objectives we've already gone over. Here's the 20% biomass limit, and you see that we really don't ever hit that with any of these results. The 2 lines are a 30% and a 36%, so this might be a good proxy for MSY target, and this might be a good proxy for an RSB and EY target. And so what you can see is that for either of these, operating under a 30-20 control rule, which is light blue, the target would be for an MEY would be about a 42% input SPR and maybe about a 36 for the MSY. And that's somewhat consistent with the equilibrium analysis. And then finally down here, the probability of being greater than 30%, which you want to be 80% of the time, is SPR of about 45%. So a lot of these objectives are just leading us back into that SPR range of 40 to 46% that we've already seen, that the MSAB has already agreed upon, which is interesting because I think this is also identifying some of their implied objectives. When they made that decision, they didn't have these objectives, but they still wanted an SPR about 40, 46%. And I think it's because of these targeting type objectives. Any questions on that? What I'm going to move on to next are the final 2 coastwide objectives. Great. So there's a couple of more, 2 more coastwide objectives: limiting catch variability and maximizing directed fishing yield. We've seen these, except that for the ad hoc working group has proposed making a slight change to the catch variability, and instead of using an average annual variability or AAV type statistics, which averages over a 10-year period, they were really more interested in, we really don't want the TCUI to change more than some percentage in any given year. So we've moved this objective into what I'm calling annual change. And that's just simply a statistic on what is the change of every year, and does that change exceed 15% in a given year? I believe the SRB had some discussion around this at the last meeting.
Did you guys talk about putting it as part of the management procedure?
Yes, so,
Really?
yeah, so one of the, in that coast-wide MSE evaluation, we had different constraints in there. And one of the constraints was the TCY just can't change by more than 15% in any year. Another thing I tried to look for, but you know, these simulations take time, I tried to find the actual management procedure that would result in matching this tolerance and this change, which would mean you could change up to 18% per year because it's not changing that all the time. But that never really came out. We tried some other constraints of slow up, fast down approaches. You know, it's always limited in some way, multi-year quotas and other things like that. And the result was we needed some sort of constraint. There's so much variability in the population that we needed to have a constraint on the TCY to meet this objective. So I think moving forward, we'll actually introduce constraint in the management procedure to meet this objective. And then just noting that the ad hoc working group report from that is supplied as an info document for the SRB and will be presented to the MSAB as a info document for the MSAB to actually be introduced into their discussions. So that's the coast-wide objectives we're operating under. The conservation of, or the distribution objectives are what I'll go over next. And these are things we've been discussing at the ad hoc working group meeting. So first of all, we've had the discussion with the SRB in the past, the concept of conserving spatial population structure. And so we've defined this at the biological region level. And basically, we thought an objective would be to maintain some minimum proportion in each biological region. And so that's relative to all other regions, not some minimum proportion actually within the region, but that the biomass is spread out amongst regions. So we haven't actually defined those proportions, but one suggestion I had to the MSAB working group was these should sum to a value less than 1 to give you the flexibility. If they sum to 1, then you're sort of fixed in there. That is what it has to be. But in any given year, the proportions are going to be different. So this is sort of a minimum standard. And we can use a number of different tools to define this. The observed historical proportions from the FIS data or the modeled FIS data. We can look at putting together a model that has some sort of equilibrium biomass in the different areas. Say, as Ian did when he presented the spatial stock assessment, he said, these are my assumptions about migration. What if there was no fishing? This is how the stock would look in equilibrium. And then say it can't be less than 20% of the biomass in each of those areas. And that can be then used to calculate your proportions. But that depends on the model that you put together. And then, or you could simply have agreement on that. So it might be useful if the SRB has any thoughts best how to do this. I think the MSAB and the commission may actually look to the SRB to supply any advice on defining this objective, conserving spatial population structure. Another objective that or that the MSAB has defined as useful is sort of this objective of maintaining biomass around a target that optimizes fishing activities within a regulatory area. And this gets pretty complex to me because regulatory areas are not independent. So you can't really do like a MSY or MEY type target calculation. But one thought we had is I think that this is really more or less related to a CPUE type concept, that they have enough fish that they can operate their fishery in an efficient manner. And so we thought, well, let's let's define this objective using the amount of O26 biomass. And as long as there's some O26 biomass in each regulatory area, then the fishery has a biomass, an exploitable type biomass to operate on. So we'll work with them on, and maybe do some analyses potentially that would help define these proportions. And so in other words, this could be some sort of distribution of O26 biomass that gives opportunity to all the different regulatory areas.
So those would be specific to each regulatory area. In other words, not one value for all.
That's correct. Yeah, they could be. So that's an interesting point, is that when we're defining these objectives for each regulatory area, which is the subscript A, that they could have their own defined proportion as well as a tolerance here. But I think one way we're looking at this is that it's a proportion relative to the coast-wide distribution. So I think here it would be a working together to define a distribution of O26 biomass, which would then define all of the proportions. It's not saying I want 20% of my area and I want 80% of mine and 60% of mine. It's just relative coast-wide. On that note, you could potentially define you want a minimum number of O26 fish in a regulatory area, which becomes a independent regulatory area concept then. I'll talk about that on another objective here. But we're working with MSAB on this one. This hasn't been given a high priority, but it's something that they've expressed interest in the past. We talked at length with the working group about limiting catch variability within a regulatory area. So remember, we have this concept at the coast-wide level, limiting annual changes from year to year on a coast-wide level. And I thought, well, is there some sort of redundancy in defining this on a regulatory area level as well? If the catch limit is not changing on a regulatory area level, then it's probably not changing on the coast-wide level as much also. But the ad hoc working group felt, let's leave them both in for now for different reasons. They saw defining an objective on the coast-wide level was to address sort of assessment uncertainty and those changes year to year that the assessment has on the coast-wide level. The objective on the area-specific level would be addressing uncertainty in the distribution procedure. And so it's trying to capture two different things. We'll see how this works out. For now, we've defined it exactly the same as the coastwide. The MSAB will actually discuss if they have different tolerances and different thresholds on specific area level. This was the fun one, an objective related to maximizing directed fishery yield. So there's a number of, I would say, potential objectives here. And I'm going to start just by looking at this second one, because this is how I thought about it. I thought originally defining an objective of what is your minimum level of TCUI in your regulatory area that you are willing to accept. So for example, they might have a level that the TCUI has to be 5 million pounds for them to even operate a fishery, right? Or maybe it has to be 2 million pounds or something like that. Can you actually define that minimum level? And the regulatory area 2A actually has defined that level, and the commissioners at the annual meeting made an agreement upon that level of 1.65 million pounds, I believe it was. So there's actually a paragraph in the report that says for the next 3-year period or something like that, that 2A will have a 1.65 million pound TCUI. In contrast, and moving on to this sort of measurable objective there, is Area 2B defined their objective, which was actually implemented by the commission at the annual meeting. They have an objective related, they want a certain proportion of the TCUI in their area. And they right now, I think their objective's 20%, but they had an algorithm that modified from 20% based on what had been observed in the stock distribution. So Area 2B came at this with an objective of we want a certain proportion of the coastwide TCY, and 2A said we just need this absolute amount to operate under. And we had a lot of discussion about this, which one's the correct way to look at this. And at the end, I came to the conclusion that both are different ways to look at it. Looking at defining an absolute minimum in a regulatory area is looking within your regulatory area and not considering the consequences on other regulatory areas necessarily, but it's really looking at what are my needs in my regulatory area. The proportion is looking at what are my needs in my regulatory area given what is the value outside of all the different areas and what's the sharing between the areas. So you have a little bit more view of looking between the areas. And I think defining both of these objectives is useful in this process. And if a regulatory area can define both of them, I think it would be interesting. And of course, that's the nice thing about MSE is we're evaluating trade-offs between objectives, so we can have competing objectives defined. So that's those two, and we're going to work with the MSAB on those. If you have any experience or suggestions on those, that would be great to hear. Another interesting concept that came up in the working group was, what if we had an objective that maximized the TCUI for all areas jointly? And we thought, well, that would be a great way to define this objective. However, we don't know that is the objective of the commission to maximize the TC in all regulatory areas at the same time. In fact, they might want to shift TCUI from some areas to other areas for economic and social reasons. So I'm not sure that this is really a good one. It's interesting in theory.
It's the only one that's related to the general objectives.
Right.
The other ones are not. I mean, setting minimum absolute levels has nothing to do with maximization.
Right. Yeah, you're right. That's true. Yeah, we might want to redefine this general objective as being providing opportunity for.
That's similar to the one you were just looking at before.
Yeah. Yep. So maybe some of these can be moved up into that one.
Sorry, Al.
Yeah, go ahead.
Just very quickly, I mean, you already mentioned that the second and the third one are competing objectives.
Potentially competing, yeah.
Well, I mean, they are competing. Whether they get to the trigger point is a different ballgame. But my feeling is that it's going to make the trade-off discussion very difficult, because in many cases, you have to treat one nested within the other, and you can't do that with these. And so you might say, oh, that only fails 5% of the time, and that only fails 5% of the time, and we're okay. But actually that means 10%, you have to do 10% of the time you have to do something. So the evaluation is going to become really difficult by that interaction between those two. I mean, it doesn't matter from your simulation perspective, but how do you expect them to make a decision on that when they're not independent?
Yeah, I'm not sure. I haven't crossed that bridge yet.
Yeah. Okay, and
another
obviously depends very much on what they choose. If they're quite,
right,
restrained and choose a very low minimum, it never becomes a problem. But then you don't need the rule.
It's sort of similar concept to the biomass limit and the biomass target and the biomass threshold that I've been thinking about too. Is those can become, you meet one of them and the others become moot objectives, right? But you don't know which one's going to be the objective that actually defines the evaluation. So you might say, and that's where prioritization comes in. With the limit, none of the simulations I've done actually get close to the biomass limit. So that objective's always met. Let's move on to another objective. Okay, this one's always met. Let's move on to the next objective. Oh, this one's not met. Oh, showstopper, right?
Yeah.
That could be a way to do it. The other thing that I was thinking is that there were just such different viewpoints on how these objectives should be defined. Should it be an absolute level or a percentage? That we came to an impasse. And that's why I thought, let's leave them both in. If a regulatory area wants to define only one, that would be fine. And then a different regulatory area defines a different one, and that would be fine. They don't care about the percentage. And then we just operate under what their individual.
They don't care about they don't care about the other one until they realize, actually, my overall share is declining. You see, so they're conditional upon each other, so you can't see them independent of each other.
Right.
You do say, oh, this one does this one does this, everybody's happy,
Right.
and then you calculate it for them, and they'll go, well, hang on a second, why is all the catch moving over here?
And that's why, in my mind, MSC is iterative, is people are gonna learn that as they go along and they start seeing results. So yeah.
I think you should, at this point in time, evaluate them independently, i.e. do an see those values as separate. If you use this type, then
This would be the
this would
evaluation.
be, because once you allow different people to have different rules, then the whole thing becomes very complicated. And I think
Yeah.
maybe you could say, well, if you have a percentage, you're going to get above your level 90% of the time, so you can then fill in the tolerance for that other one and work it that way around. That way they're not dependent on each other.
Yeah, that's a good approach. I'll definitely try to do that. The thing that we're ignoring, the big elephant in the room here, is that getting all the regulatory areas to fill in these values is going to be challenging. Because I've been asking them, what is a minimum TCY you want in your area? And 2A is about the only one who's really come up with anything. But, we'll help them in that process.
Put in 0 if they don't give you a value.
Exactly. Well, and that's the thing. And then that first iteration, they're going to see the results, and that's going to make them realize how important it is. That's a serious option for me.
Yeah.
It's not funny. It's serious. Okay, then. The next, another objective that still hasn't been flushed out is some stakeholders are very interested in, well, they've been concerned that they haven't felt that the catch limit or the TCY in the regulatory area has actually followed the trends of abundance in their area. So for example, the survey may have been increasing in abundance, but their TCY had been dropping, and that's because the coastwide TCY had been dropping, et cetera. It's a complex process, but they were interested in having an objective related to that concept that the catch limits are, I'm saying linked to abundance, but I know where that's coming from. But that it is indicative of the trends in their area. And so that's what thing I want to discuss with them is, do we need an objective that says the TCY is similar to what the fisher people are observing in their area?
We've seen this done in Europe a couple of times, where people have used the survey as an independent estimate of a continually changing distribution. And the trouble is, you get one survey estimate. You might have to, I guess you could use the space-time model to get different variations in it to get your estimate of variance, so that you can look at tolerance levels. But so you could then redistribute your catches in proportion to the survey, the proportion of targetable biomass.
Yeah. And we're already doing that. I'll talk about that in a moment, the management procedure part of that. Yeah.
I mean, this seems like another one of those cases where they're conflating objectives and procedures. presumably one of the procedures you could evaluate is set the TCUI by area in proportion to the survey, which would implement this directly.
But setting the TCY in proportion to the survey would not necessarily meet their objective that they have a certain percentage.
I don't understand why that would be relevant. You know, if you're trying to maximize local fishing opportunities, what does it matter what someone else has in some other area? Because that's what the proportions are determined by.
That's, I mean, it's obviously important to area 2B because they've defined they want an allocation of 20%.
But that's not actually, it's not like Hake, right? Hake that says, what is it, 24% goes to Canada and the rest goes to the US. So that would be a legitimate objective. Like, we want our 24%.
Right.
In this case, the percentages are changing all the time and it's not actually written explicitly anywhere, as far as I know, in the treaty. So yeah, they may want that percentage, but there's no reason for it. Like, you could say, okay, well, we'll give you 15%, but it's 10 million pounds, or you can have 20%, but it's only 7 million pounds.
Right.
Which one are they going to choose?
That was the discussion we were having at the working group meeting. It was, yeah. And yeah, and so I didn't know how to get beyond that. They were very adamant that they wanted this phrased as a percentage. But you're right. And so on conflating management procedures and objectives, the way that I've been seeing is you can define an objective or you can define a management procedure. You can bring that objective into a management procedure. And yeah, you do want to be careful about conflating them. In this context, I see the objective as slightly different than the management procedure itself. If the objective was that we want 20% in our regulatory area, say, and then you define a management procedure that says always give them 20% of the coastwide TCUI, then you would always meet the objective. And then if you define a management procedure for 30%, you would not meet the objective. So that's the conflating part, right? And so I think we want to be careful about that. But I've been using the definition of objectives to actually sometimes develop management procedures. Do we want to take this objective from the evaluation process and just put it into the management procedure? Or do we want to keep the objective as an evaluation process?
I mean, everybody's going to want the highest percentage possible of the TCUI. I don't see why this would be an objective.
Yeah. That's a good point. I mean, the SRB, I'd love to have some note to that sense to help us narrow down the thoughts here. I was always came at it from this level. I had one objective defined in here, which you're right, is not maximizing directed fishing yield, but maintaining it above some minimum level, thinking of it as a limit.
I mean, that one is more, like, it obviously doesn't get to maximizing yield in any way, but you could have a separate objective or whatever that's the minimum tolerable biomass, or not biomass, but TCUI,
right,
to maintain a viable fishery. I mean, that's a legitimate objective.
It's just some sort of economic element.
Exactly. Yeah. Okay, so just to, if you're okay, I'll just move on from this slide. It'll be discussed at the MSAB, and of course, I'll always just present the range of TCUI by regulatory area that comes out of the simulations as well. So to summarize, there are a number of objectives here. I'm going to look at narrowing those down, maybe prioritizing them with the MSAB coming up. But to summarize, these are the coastwide objectives that I've presented to you today: a biomass limit, a biomass target, a biomass threshold, which is a lot of biomass related objectives that might be interacting with each other in some way. And then we have a yield variability and maximize the yield objectives as well. Objectives, whatever that word is up top, is these are distribution objectives, and these are done either by region or IPHC regulatory areas. And by region is just that objective of conserving spatial population structure. And then for IPHC regulatory areas, what's on the table right now is maintaining that proportion of coastwide O26 in each area, limit annual changes in the TCUI, maintaining the TCUI above a minimum absolute level, and then the percentage of coastwide TCUI across regulatory areas. So those will be discussed at MSAB. Any thoughts you might have to guide that discussion would be appreciated.
I have a question about the regions, and I know that we've had this discussion here, but at the last MSAB, one of the MSAB was wondering about restructuring Region 2 so that 2A and 2B were together, and then 2C was lumped in with, I think, the rest of 3. And so, and I think it sort of makes sense in terms of the way that the annual meeting decisions went in terms of, okay, we know how 2A's allocation is going to be decided, we know how 2B is going to be decided, so, okay, everybody else can figure things out.
Right.
So I guess my question is, if we're looking at the bioregions, I remember our discussion was that, you know, the boundaries between the bioregions are pretty squishy already. And so if it was decided that the regions that people want to look at the MSC, at the MSAB, would be 2A and 2B, and then decide to move 2C in with the rest of 3, is that going to cause issues?
Well, I think in
The whole idea of bioregions was to not have it have anything to do with regulatory areas.
and that's what we're doing here. I mean, the conserved spatial population structure is not is an objective, a biological sustainability objective. And that's why all of the fishery objectives are at the regulatory area. So we're not trying to force fishery objectives into regions at all. We can do whatever we want with fishery objectives. If we want to combine 2A, 2B, we can keep them separate, et cetera. I think where regions concept might come up is in the development of a management procedure. And I'll discuss that coming up in this presentation shortly.
The other issue there is that although the lines are somewhat arbitrary and squishy, they're squishy in the other direction. So 2C is much more like 2B and 2A, and the eastern end of 3A is more like them than the rest of 3A and 3B. So if anything, it would go the other way from a biological basis.
From a bioceanographic perspective, 2A might have an argument to being split out because it's a different sort of ecoregion south of Puget Sound.
Which it was originally Area 1, right?
Right, that's true. Yeah, it's originally 1, but 2B and 2C, they're just, yeah, they're so biologically linked.
It's a approximation to get at this objective, basically. But let's hold that thought until we get to management procedures, if that's okay.
Just have one clarification on some of the discussion. Has it ever been talked about the historical variability between reg areas and regions?
We haven't
got really good data on that, how variable it is over time, and maybe that's the basis for, I mean, maybe that could inform what MSAB kind of brackets things. So then instead of saying we want to fix 20% or whatever it is, you know.
And that was part of the discussion with the commission decision on Area 2B, I believe, was we have seen historically about 20% or something like that. It's actually in the paragraph that's written. And so they're basing part of the algorithm on that historically observed percentage, and then also the stock distribution over the last 3 years or something, and averaging those numbers. But it's definitely something that we look at. It's a good point, Jim, that we should probably have those numbers ahead of time before the MSAB meeting to assist with that discussion. And we'll also look at things like the historical stock distribution estimated from the survey and things like that as well.
It is kind of odd to base it on the history, isn't it? In the sense that then it means you don't need a new management procedure if that's what you're aiming for. You just do what you've always done.
And that would, oh, well,
Now, the history is
that won't
more-
go over down
I'm
well
thinking
here.
more for bracketing, like, and
Okay.
pointing out that it's not a static system, there's gonna be variability that's been observed.
Yes, but
The extent that
presumably
it's
you're
happened.
trying to improve that variability in some instances in here by your management procedure, because, you know.
I mean, I think it should inform the operating model, and it should inform what management procedures should be developed to recognize. I think, I mean, I guess the main point is that it's not static, and even though you might have management procedures that are static, it's going to be unlikely that you'll always have the same fishing conditions.
Right. So if it's okay to move on to management procedures, the objectives was actually going to be a main part of the MSAB meeting coming up. The management procedures are still in development. So to remind you again, we have this illustration of our harvest strategy policy with the management procedure split into scale and distribution components. A quick slide on the scale, stuff that we've been thinking about this is a illustration of our harvest control rule with that, again, procedural or input SPR on there that then gets fishing intensity on the vertical axis in SPR. And that SPR fishing intensity gets modified depending on your stock status. And right now that's a 30-20. And something that we've been thinking about a lot and want to point out, there are reference points that are used for defining objectives. And then there are reference points that are used as operational points in the management procedure. And we're just trying to separate those two concepts. Again, partly because of the SRB the comment of conflating these two. So one thing I just want to point out to the MSAB and the SRB as well is that we have this limit, a biomass limit for a control point in the harvest control rule, as well as a limit defined in the objective. And they currently are defined as the same thing, but they don't necessarily need to be, and that's 20% of B0. We also have the trigger and the target, where the target is an objective and the trigger is a control point in the in this control rule. And so just trying to separate out those two concepts again. A quick review of the interim management procedure, what we've been doing the past couple of years at least, and there's two components to the distribution part. The first is stock distribution, and this is estimated from the space-time model, the mean 032 WPUE in each IPHC regulatory area. And this is again linked to that biological sustainability objective, preserving spatial complexity. A couple of changes that we are considering are the use of biological regions instead of regulatory areas, as we just mentioned. And then the uses of the all sizes WPUE index instead of 032, because the fishery is the TCUY is mostly 026, and the all sizes WPUE from the survey is mostly 026 as well. So it just seems more congruent with the TCUY, which is what we're trying to distribute. Those are some concepts we are pushing to have come through in this management procedure evaluation coming up. Yeah.
I'm not sure I'm following so you're proposing to use biological regions in the management procedure?
Yes, and I'll show you exactly how in a moment. As one potential step in the management procedure.
Doesn't that go against what you just said, of conflating the procedure and the objectives? Why would you need to do that? Why would you need to maintain consistency between the objective and the MP?
I don't think you do need to. But what I'm going to propose is a framework for developing management procedures that does use regions. It doesn't necessarily need to, though. And as we see, the current interim management procedure does not use regions, but does use regulatory areas. We do need to get to regulatory areas eventually. It's just an intermediate step in getting there is to go through regions. And I think that that's what Anne Marie was getting at. Like, do we need to have these regions defined this way when distributing the TCUI? We'll talk about that in a moment. So this is just looking at the current interim management procedure and identifying where maybe some inconsistencies are as well, and thinking forward in development of these. So that there's two parts to distribution in the current interim management procedure. That's stock distribution. It distributes the TCUI based on the current stock distribution estimated from the modeled survey index. And then it shifts that distribution based on relative harvest rates. Basically, it says we can harvest at a higher rate in eastern areas than we can in western areas. And I've put here sort of a real brief justification of how these relative harvest rates were come up with about a decade or so ago. And that was in the old harvest policy that incorporated a blue line. It actually used harvest rates of 16.125% and 21.5% for these two different eastern and western areas. Now that we're on SPR-based approach, we don't need to define specific harvest rates, but just relative to another. And so what's been defined in the current interim procedure is that areas 3B, 4A, 4B, 4C, D, and E are 3/4 the target in other areas. So that distribution just slightly shifted into the east. The TCUI shifted to the east. Again, this adjustment shifting from western to eastern areas is on more or less justified for biological reasons based on productivity of these different areas. And so we've been thinking about this a little bit, and really there's science-based reasons to do this, like looking at productivity, thinking about immigration and immigration, and there's also management-based reasons. And the management-based reasons might be, well, for social reasons, we don't need to harvest as much in this area and we can shift some to this area, or we're not as certain about our data, we don't have a long time history, things like that. So that there's these two different concepts we're trying to separate out. What are science-based, what are policy-based? So what we can do, Pierre and myself especially, is conduct research on productivity to inform the science. Enumerate uncertainty of data in each region to help with policy decisions, and then consider other factors. But then remembering that regardless of what we choose for a management procedure on what relative harvest rates are, we're really identifying management procedures to evaluate in the MSE that best meet the objectives. So this is really guidance on how to develop management procedures. So to help inform the development of these management procedures, and the MSAB has actually requested this in the past, is Pierre and I looked at productivity by biological region. And we did this through a yield per recruit analysis, which basically we looked at the 4 different biological regions, and I realize I don't have a figure, and it's not till later in this presentation, but that's the regions 2, 3, 4, and then 4B out in the west. We looked at just one fleet, that's the commercial directed fishery, 2 sexes, and tested 3 different scenarios of weighted age and selectivity. So we basically wanted to look at productivity at 3 snapshots in time as we thought they would be estimated. So they're bringing in lunch, if that's all right with people. I'll continue on. So we looked at a scenario using what weighted age was in 1985 and what selectivity was in 1985, because this was a period of when weighted age was high and the biomass was at a really high state. We also looked at the period 1999, which was when the analysis of productivity and other reasons was done to justify shifting the TCUI from west to east areas. So this is Again, Clark and Hare looking at different things and making decisions to have lower harvest rates in western areas. And that occurred around the late 90s. And then we wanted to look at the current period, 2018. And then as a sensitivity, we took those selectivity curves and shifted them to the left just to see how selectivity affected our results. And the measure of productivity in this yield per recruit analysis was F0.1. And this really is, there's no maximum to the yield per recruit curves in halibut because really they don't stop growing. Weighted age just keeps increasing as they get older and older and older. And so the maximum is just not a reasonable measure of productivity. So here are the actual yield per recruit curves for the 3 different time periods. You can see 1985 on the top, 2018 on the bottom. The different colors are the regions, where the black one is 4B, which is obviously different than the others, and the others aren't all that different, although region 4 is in the red. I'll present a table that will help summarize these results, but basically what you can see up here is the blue and the green in all of these plots is very similar, and that's regions 2 and 3. 4 is slightly different in these 2 years, but very similar in the most recent year. And then 4B is always off on its own, doing its own thing, suggesting a lower harvest rate for area 4B or region 4B. So we put together this table, and looking at the top 3 rows of this table with lots of red in it.
Color coding.
Yeah. We decided if we're going to color code it, we're just going to go with the color that people hate the most.
So this means the productivity is terrible.
Yes.
And red is good in this one.
Red is good
Red
in
is
this one.
good, guys.
You've ever seen a presentation from Grant Thompson? He color codes a lot,
yeah.
and that's the first thing he says is, don't interpret my colors.
Stop color coding.
Yeah. Anyways, yeah, we could get the same message across without color coding. But everything is relative to region 3. And so it says relative to region 3, area 2 is the same harvest rate. But area 4 in the early years were about a little bit less. But in that most recent year, it's very similar. And then area 4B suggests their productivity is quite different and should have a lower harvest rate. Shifting to a younger selectivity, shifting that selectivity curve to the left, suggested area 2 or region 2 is a little bit different, but it doesn't really change the overall interpretation of the results in my mind. But this analysis showed that when Clark and Hare did their justifications and their productivity analysis, that this agrees with their results, but it's not necessarily the same now. So as Ian presented earlier with bycatch or non-directed fishery discard mortality, that things change over time. And that's what we're seeing in this yield per recruit analysis. So it could be time dependent on if you want to incorporate different relative harvest rates.
Sorry, where the selectivities come from? Is it?
It's from the estimated selectivity in the assessment model. So the weighted age and selectivity are coming from the assessment model, and then the parameterization of the yield per recruit is coming
Just
from.
the areas of fleets model?
So what are you
Was
doing?
it only the long coastline? No, it was the areas of fleets. It was the long areas of fleets model.
Right.
And these are
Ah.
parameters.
Because you go back to 85.
Right.
The short model starts more recently.
Yeah.
Then
Yeah.
The long.
those selectivity curves are gonna be confounded with movement.
With what? Sorry, I couldn't.
Movement.
They're relative to the coastwide stock. So if in the case of a yield per recruit, I think you can interpret them as what you're getting relative to the whole stock.
An indication.
So they're reasonable to use here. They're not reasonable to use to describe
Sure.
the gear selectivity or the contact selectivity.
And that's why we did a sensitivity. We just wanted to see is selectivity really going to move this? It changes the results slightly, but you know, so it is a consideration. Selectivity has a big effect on yield per recruit. But it's something we'll discuss with the MSAB. They may look to the SRB as having reviewed this analysis. it's not meant as a definitive result of productivity, but something to guide the discussion of what harvest rates should be relative to other regions.
Also, in the areas of fleets models 2 and 3 are the same selectivity?
No, they are different selectivities. They just happen to come out with this similar yield per recruit.
Oh.
So you can see here that red and blue are green and red, green and blue, region 2 and 3 are very different yield per recruit curves, but F0.1 is at the same point in the same relative harvest rate.
So the shape of the selectivity curve is more or less the same, but in one region it's just shifted to bigger fish. The shape is exactly the same. It's just.
We put the selectivity curves in the document.
I think no, maybe not. No, I don't think there is another selectivity.
We can take a look at selectivity if needed.
Yeah.
Given that your fish move around quite a lot, in reality, how sensible is it to assume the productivity by area?
Yeah, that's a good point. And part of the decision for relative harvest rates being different in western and eastern areas in the past was that there is sort of a net migration into the east, where the eastern areas tend to get fish, but they're moving from the west to the east overall over their lifetime. So it was thought, that was another justification at that time for them to have the relative harvest rates. But what we've also noted is that these biological regions do have differences in weighted age observed between them. So they're not mixing at a very high rate, at a rate high enough that they actually are experiencing potentially differences in productivity within themselves. And especially 4B, and that came out here, 4B has been identified as potentially being genetically distinct as well.
Or they're mixing at a rate that's not demographically independent. So if all the fast-growing fish are going to the east side of the stock, you can have a high rate of mixing and still have very different productivity in terms of yield per recruit about where you put your harvest. Well, unfortunately, we can't unconfound that.
No, it just points out that there's probably interactions that we're not capturing. So productivity here means environmental productivity as opposed to fisheries productivity, or is it the combined effects of fisheries productivity and environmental productivity, i.e. selectivity and growth?
Yeah, that's probably, that's a good way to put it.
So none of these models take into account reproduction within versus immigration from without.
No, it's, just on a coast-wide sort of thought process, just looking at what's been observed within those regions. When we get the operating model running, we might be able to look at things like that, do some more investigations. So that's the yield per recruit analysis, and that's really just meant to guide the discussion on how we're going to develop management procedures related to distribution. Sean, just cut me off when you want. I'm on slide 31 of about 42, I think, here, so it's getting somewhat close. And I'm happy to present through lunch too, if we've done that in the past.
How long do we have for lunch?
Note that we do have
An hour.
an hour and 45 minutes for revisiting the stock assessment tomorrow. So potentially there's some time available there as well. I don't have anything else to present at this point.
Yeah, so I'll continue on if you would like. And there might be a good break point coming up for the last like 3 or 4 slides, or we can just push through. We'll see where
Well,
we're
we
at.
only have 5 minutes until lunch.
Okay.
So do we want to open a new topic?
Well, this is still related to management procedures. This is sort of the framework that we're looking at to develop management procedures.
You're talking like slide 42 is the
rest of this topic, or?
No. This has probably about another 5 minutes, I imagine, of
All right.
presentation.
Let's do
Yeah. Yeah, okay. Yeah, this will be quick to get through, and then we'll switch topics into the technical details. So this will be good to finish this up. So given that background, given how the current management procedure is implemented, and the thought of biological regions, linking these things to objectives. So I'm not trying to conflate them, but I'm trying to link different elements of the management procedures to the objectives. And so we have a framework for distributing the TCY, and that framework is, let me maximize this one. First step is always to calculate the coast-wide target fishing intensity. That's the scale portion. And then there's regional stock distribution, which is science-based, and that basically distributes the TCY based on how the stock is distributed amongst the regulatory areas. Then there's the regional fishing intensity, which just basically it shifts some distribution, and this is a science-based thing. Maybe we make a decision based on productivity or something, that we want to shift away from 4B into the other areas, shift TCY from 4B to other areas. And then there's a regional allocation adjustment, and this is just providing the option to, again, further shift the regions, the TCY amongst regions based upon any sort of policy decisions. And then finally, within a region, we want to get to the regulatory area level. And I have some graphics that will help describe what I was trying to do with my hands there. But these are basically 5 steps in a procedure that we can insert into a management procedure to implement and evaluate in the MSE. Now we note that all of these steps are not necessary. And in fact, the current interim procedure only has steps 1 and 5. And those are the only 2 essential steps here. You need to define the coast-wide TCY, and then you need to get that to regulatory area. There's some intermediate steps that we think will help in the process. So the first thing, coast-wide TCY, as you can see in that figure there, and separating that into an O26 and U26 components. The stock distribution then determines how that TCY is distributed amongst the regions. And as I said earlier, that the best thing to do in this one would be to use all sizes WPUE because it's most congruent with TCY. And this would get at potentially satisfying biological sustainability objectives. Not necessarily satisfying the exact objective, but try and get at that. The next one is the regional relative fishing intensity, say based on estimates of productivity, migration, and other scientific characteristics to get at biological sustainability objectives. That's conserving spatial population structure. So that changes the region boxes slightly. And then regional allocation adjustment would again change those region boxes. And these could be met based on different policy and other things like that. So it's just identifying steps in here, and this would get at potentially fishery objectives. And then the final step is distributing to the regulatory areas within region and not exchanging amongst regulatory areas across regions. So all that exchange across regions would be done at the upper level. This would then, now you have your TCY in a region allocated to the different regulatory areas. And this could be based on a number of different things, as simple as agreements of percentages within a region, or even CPUE trends or biomass trends in the survey, or whatever you want. So this is where some creativity will come in. That's the 5 steps, not forgetting that there's a decision step at the end of all of this management procedure, which may have unpredictable consequences. And that will be something we'll model in the operating model as implementation variability, not ignoring that, but seeing the effects of that in the MSE operating model. So that's the end of the management procedures, and what we have left to present are that's a couple of slides on technical details and how we're thinking about putting the operating model together, and then the program of work, which would just be a couple more slides. So there's really only 5 more slides in this, but there's some detail in those lines.
Sorry, Alan, just a quick question. Not sure I'm getting this right, but somehow conceptually it's wrong to do the reallocation by regions. What you're claiming is that the regions have different productivity, which would imply that if you take it from different areas, you would have to readjust your coastwide TCEY to actually maintain the SPR that you're looking at.
Yeah.
So you're just chasing your own tail in this. I mean, I don't know whether it matters in a single, because you're only doing it for 1 year, and then you get a new assessment and may reset. But on a conceptual basis, that ain't right.
So I'm not understanding what you mean by that ain't right, but I see it as you define a coastwide TCY based on an SPR, say 46%. Regardless of how you distribute the TCY, when you distribute it to regulatory areas, that distribution will have a feedback on the coastwide SPR because of the differences between the regulatory areas or regions. So what I think Ian does in the assessment is, do you reiterate that to get the coastwide SPR to match based on the distribution? We could do that in this management procedure, which would be time consuming in the simulations, or we could have just accept that input SPR 46%, the distribution resulted in an output SPR of 46.5%.
I think maybe to provide a more pragmatic answer to your question, Sven, is that we kind of agree. We thought that the regions were a logical biological first step, and then you'd have your management done below that. But we've essentially been told that there is going to be some adjustments across regions, so we might as well keep that step in here because it's going to happen regardless.
The output SPR doesn't matter. You're judging the performance based on the objectives.
Right.
Which are based on biomass and catch and all those other things. So
The output SPR may matter if you have a limit, a fishery, or a fishing limit, like an overfishing definition.
It's kind of one of those issues I think always bothers me, not in many other places as well, that, the SPR rate's a proxy for things like MSY, BMSY, and FMSY. And it seems like we, rather than say, oh, we nailed the SPR rate that we wanted to use as a proxy, it should be, how well is the fishery doing? How well reproduction going? Is it reasonable in the context of whatever uncertainty there is about MSY kind of thing?
And that's what, go on.
Anyway, that you see that a lot where people, we've achieved our proxy.
Right. And that's why the phase plot bothers me a little bit, and putting a horizontal line on the phase plot for fishing intensity is some interpretation of that phase plot is, being above that line is bad. Or you have a target and you need to be on that line. You don't. Is that vertical axis actually important? It's just an indication of how you've been fishing the stock.
I think from my perspective, what Ian said is the relevant point. It's accounted for somewhere. It goes back to just the coastwide thing. You don't end up with a mismatch.
Yeah.
That's fine.
We have had cases where the commission has adjusted the allocation among areas enough that we've gone back to check to see whether they've actually changed the SPR appreciably.
If you know what that value is, then you know how far you could be out by, and then you can kind of say, well, we could do it, but it's not really worth it. It's only a percentage or something like that, and then get on with it. But just unless you do that, somebody may argue.
Yeah.
Mostly it's in the rounding error of SPR.
But that's fine.
But depending on how far they deviate from sort of the base condition, then it can.
And how, the base condition of the distribution, as well as the magnitude of the differences in the productivity.
And where they put it, because it's more sensitive to moving it to some areas than others.
Yeah.
And it's actually not so much the underlying productivity as it is the distribution within areas out to all the various sectors. So you have a huge recreational sector in some areas that you don't have in others, and that's selecting younger fish. And so that allocation, there's feedback through the biology as well as the allocation that occurs on the sub area level.
Okay. Anything else here before we break for lunch?
I'm gonna get mine first because I gotta leave at 1.
Jim's cutting the line, so maybe we'll take a half an hour.
Okay.
Try to eat quickly and
Yep.
if
You know,
not,
I gotta be gone at 1.
so you're gonna be going out at 1.
I just have to be on a phone call at 1, still got a half hour.
Oh, okay.
So.
Should take an hour then, so you can come back.
Yeah, all right, well, we can take an hour. I mean,
Okay.
I can keep myself busy.
If, I mean, I'm not sure what Mark is doing, but if you want to grab lunch, have me present for a little bit longer too, to save time, I'm happy to do that as well, but it's up to you. Or we can just have a relaxing lunch.
Is that through lunch? Just get it.
I could actually use a bit of a break.
Okay. Let's come back.
Our former vice chair suggests that we take an hour.
Okay.
Yes.
Sorry about that.
See you at 1:30, Mark.
See you at 1:30.
So
Mark, if you're back online, we should be unmuted.
I am back online, and I woke up from my nap and I saw these beautiful pictures of people fishing.
Yeah. Okay. I'll get started then. Just to finish up this presentation, the last little couple bit is the update on the development of the operating model and some of the thoughts going into that. And then a look at the program of work. So let me maximize this. Okay, so Steve Barikoff's our programmer that we're working with on this MSE team, as I've been calling it. And he's in Colorado. He should be listening online. And he's been doing some fantastic work on developing the operating model and getting the framework together and really bringing in some concepts that, one, I would not be able to bring in, and two, I hadn't even thought about bringing in. So he's developing the operating model in C++ with a lot of different things, such as tools to actually slice and dice data into thinking about it from a fish perspective, into ages, regions, regulatory areas, things like that. Development very generalized, and we are, as we develop and come up with concepts and ideas, we're writing this technical document that was document 10, I believe, on the for the SRB meeting. And that technical document is a living document. So if you did look through it, you might have noticed that it was very incomplete. And that's because, one, we've been doing a lot of things other than writing the technical document, but we're trying to write the technical document as we develop the model so that it's really current and is reflecting the ideas that we're putting into this operating model. So we'll bring that technical document back at SRB015 next June. A couple of things just to note in development are it's in our list to standardize the output to compare with stock assessment data. So this was a request from the SRB that we can be able to use the operating model to do some tests on the stock assessment model, which will be fun. And that will validate the operating model using two external models as well. Pierre's written a more simplistic model in R that has some movement, or is writing, I'm not sure where that's at. But we'll use that to verify or validate some of the more general operating model, as well as use stock synthesis, just to make sure that we get the operating model doing what we expect it to do. We plan to condition using likelihood data. We'll see where we get on that. And then, as I said, Steve's come up with some great ideas on partitioning data. Here's just an example using zip code data, and a few lines of code can do what he needs it to do. So I'm looking forward to seeing the outputs of all of that. A little bit of upcoming work is, we're implementing this closed loop simulation, and we just sort of got to bring it together. And that'll be our task between basically the MSAB meeting and we're looking at, maybe just shortly after the annual meeting that we have this operating model running. We can start doing experimentation with it and then bring it back to the MSAB and the SRB in May and June for an initial look at it. So just wanted to pass a couple of ideas that we have on how we're doing the modeling by the SRB. And this is mainly related to movement. First, here's the picture of the biological regions, and you can see the regulatory areas underneath those. And a regulatory area does not span across different regions. So a regulatory area is a subset of a single region. And because our current understanding of movement on an annual basis is really between biological regions, we're going to develop or specify the operating model for the population dynamics to occur at the biological region level, meaning we define a movement rate matrix for movement between the 4 different regions. And this was how Ian had initially set up the multi-area stock assessment model. And so we have a starting point there, at least in the parameterization of a movement matrix. And another task we'll be doing is defining scenarios of movement, variability in movement, and things like that to actually implement in the operating model. But regulatory areas are of interest, and fisheries will have to operate in a quasi-regulatory area level within a biological region. So it's not a problem. The assumption within a region is that within the year, fish may move anywhere within that region between feeding migrations and spawning migrations. And the next slide will talk a little bit more about that. So what we're going to do is model fisheries as almost areas as fleets approach within these regions, meaning you have a fishery operating on a pool of biomass, but it has a selectivity curve it operates maybe at a certain time of year, and that's reflected in the selectivity. We will need for, as you saw, there's regulatory area specific objectives. There's maybe the management procedures related to data by regulatory area. Yes, Sean?
I just wanted to, so that kind of assumes that you've got similar trends in the regulatory areas within regions.
Right.
What if you have some regulatory areas that have different trends in the historical data? You'll kind of switch that assumption to being all the same.
Yeah, so the assumption now is that within a biological region that is reflective of the dynamics of the stock, but regulatory areas may have different trends for other reasons, whether it's fishing or localized abundance or something like that. But what we're assuming in this model is that regions are basically mixing. The pool of fish within a region is able to be, or fish can occur anywhere in that region at a specific point in time in a specific year. And that movement basically occurs across the years. So you're right, that method is not going to really capture regulatory area specific trends in that sense. I'm proposing a method that might capture it, but in defense of going this way, parameterizing a movement model to the regulatory area, I think might have more misspecification than the concern that you have. And that's my concern is, we can get really fine on this, but we don't know the dynamics that we should be modeling at the regulatory area level. So should we try to do that, or should we take this approximation approach like an areas as fleets model would?
So, but you have regulatory area specific objectives.
Yes, so we have regulatory area specific objectives. So what we're proposing to do is to define a distribution of that fish within a regulatory area at a specific time of year. So we'll define the summer distribution of fish looks like this in region 2, where, it can be defined by a beta distribution perhaps, or it's simply defined as a proportion of fish occur in each regulatory area within the region. And then we introduce variability onto those proportions. So we're really just trying to capture how we're modeling population dynamics and then what the population looks like within a region during a period of interest, which would be the summer period when they're at their feeding locations, for example. That will allow us to calculate regulatory area specific objectives like the proportion of O26 in regulatory area 2A, right? We need to know that. It'll also allow us to make an approximation of, say, CPUE in each regulatory area if that's going to be part of a management procedure or something like that. So those technical details are still being developed. And it's good to have this conversation. If you have any other thoughts, ideas, we'd love to hear it. We're just concerned that trying to parameterize a model of movement between regulatory areas is going to become too complex, especially we might even have to go to a seasonal model to do that appropriately, which makes it more complex. While you're thinking about that, if you don't mind, I would like to turn it over to Piera to talk about her investigations of movement and summarizing everything that, or not everything, but just summarizing the current knowledge of movement. Mouse there if you want to use it.
So yeah, since we have to model movement, we thought that it would be nice to have a review of our current knowledge and past knowledge and try to put everything together. And that will be something that will guide the decision when we will have to build our transition matrix and when we will have to model movement. So this is a very crowded map and try to summarize all the main ontogenetic and seasonal migration observed in Halibut. It's a live map in the sense that as soon as new information will become available, we can update this map. And also it's built in layers, which means that it's very crowded now, but we can make it simpler if we want, just showing specific things. So just to clarify what you're looking at, the big regular polygons, these are the biological regions. The purple blobs are the spawning areas. The green blobs are the nursery areas. And then the triangular shape pathways, those are the ontogenetic movements. And the dashed lines represent the seasonal migration.
What is the data that this is based on?
So these are just a review of past works and current knowledge. So I've been reading a lot from the past, you know, Saint-Pierre, for example, for the spawning areas. That's a big part of the spawning areas there. So it's mostly a review. Well, the expert at IPHC have been helping, you know, defining it properly, and yeah. So, well, we know that halibut spawn in winter between November to March, more or less, in deep water at the edge of the continental shelf. And the main spawning areas are located in the Gulf of Alaska, and there is a big spawning areas in the Bering Sea and the Pribilof Canyon. So the eggs, since they spawn in deep water, the eggs are transported by deep water currents westward. And when the larvae hatched, they take advantage of both the vertical currents and the horizontal currents, so they keep on drifting westward, and at the same time they rise in the water columns. And the larvae that are spawned in the Gulf of Alaska, some of those will continue the movement and will pass through the Unimak Pass and will end up in the Bering Sea. Some of those will just be retained in the Gulf of Alaska, and some of those might end up in the Alaskan gyre and being advected in what I call kind of a larval loss area, where they don't end up in any suitable nursery, and they will just die and not contribute to the next generation. Juveniles. So as you can see in the Bering Sea, there are two pathways for juveniles. Some will just remain here and just contribute to the spawning population in the Bering Sea. Some will just go back to the Gulf of Alaska and contribute to the spawning over there. The ontogenetic movement of both juvenile and adults continue all throughout their life. And it's a basically counter movement respect to larvae, to eggs and larvae, in the sense that it goes south and east all the way down to California. Adults will undergo seasonal migration between spawning and feeding grounds. Some adults might migrate a lot of kilometers, a lot of miles, 100 miles from feeding to spawning migration, but some will just migrate from inshore feeding areas to offshore feeding areas. So that's what those horizontal arrows represent. Ontogenetic migration of adults will also bring them westward towards the Aleutian Island. What do we know in terms of segregation between spawning grounds, let's say? So the Western Aleutian are kind of separated from the rest of halibut in the sense that there is some mixing, but it's not as strong as for the other areas. The Bering Sea, we know that the immigration from the Gulf of Alaska is higher than the export from the Bering Sea to the Gulf of Alaska. So there is some kind of segregation here as well. And then there is a lot of connectivity between these two areas. However, what can be said is that, so those two biological regions are very easy to justify. And those two are justifiable in the sense that there is, within a year, there is a lot of movement within regulatory areas. And even though it's true that the border can be crossed, so the main, let's say that there are some differences between the two kind of pool in those two areas. And within a year, and especially during the fishing season, you don't really observe mixing between, or migration between biological region, but they tend to remain within each biological region. So that's a very broad overview, and trying just to summarize what's happening out there. And we hope to have a very comprehensive overview soon, just to,
Just some sort of general comments, if I could. Noting it's a work in progress as well, particularly with the area 4 and 4B, and then noting this is sort of legacy research summary. It doesn't have much in the way of indications of connectivity outside, particularly to the Western Pacific, and so that's something that will need to be amended, particularly given like the performance review is suggesting we need to do more work out that way. GSEP's been including it in the plan, and there is some research already suggesting that there's a level of connectivity there. So I think you could improve the plot by adding that as well.
Yeah, no, definitely.
This is great. When you put it up, I was like, wow, I've never seen that, but I've always thought in my head, like, what's going on? Like, where's the spawning? So this is a really good step, I think, in starting to put together the idea of what is going on here. I wonder if you could do something like, when I was looking at it, I was thinking, okay, where's the data? Like Kim even said, like, where's the data come from to parameterize this? But maybe you could put on like tagging, here's where those pit tagging studies were, here's where the larval, because I know we've seen presentations from Laurie about where the larval, larvae, so you might have an equivalent slide that says, yeah, and here's the data that informs this stuff. And maybe from that, you could identify spatially where some of the gaps are, and connect them to processes and things like that.
So that's a good idea. It's a lot of review of old papers as well, so I could actually make a list and try to refer to each one of those specific.
I know at one point in one of these processes, maybe it wasn't this one, we did talk about building essentially a data map, like a metadata map of exactly that. This is where we have data on each of these different history events.
We've done something like that, but not exactly like this. Yeah.
Kind of blending Sean's comments with this.
But in the biological.
We had something last time.
Yeah, last summer.
Presentation that Joseph put together, you have, for instance, data of, so many individuals captured, so many coded wire tag returns, so many pit tag returns.
Exactly.
Is this reality reflected in the data that you have? Have you looked at those data?
Largely, yes. I mean, that's literature that you're to build this.
And of course, you might have some halibut that just decide to do not what this map is showing. But I guess that's one just to, give a broad overview to whoever is not familiar. So that was something also for me to kind of.
I think this is screaming out to be put on the website as an interactive, which would make doing exactly what these guys have just been suggesting. So easy to do. You'd be able to hover.
Yeah,
and it would
if you could take
you to either data or at least literature.
Yeah, here are the tag fish of certain ages. Here are the recoveries. That type of dispersion. That'd be great to see. Summarize.
And also the state information. I mean, a lot of this seems to be based on process information, either hydrodynamic models that drag things. But you could overlay your FISS data on this as well by age, for example, and link it to the other websites. You could actually say, look, that makes sense. Those are the nursery areas. That's where we catch the young ones. They're in that vicinity, you know. So I'm not saying, I don't know how difficult it is to do that interactively, but I think it would be really useful for somebody to have a look at that and actually say, well, they're both consistent. Maybe in future we can use some of that data to infer migration rates by house, you know, from the survey data potentially to help parameterize these things in the model. So, you know, there's an awful lot of opportunity, and this is, I think, a particularly nice way. I mean, I'm not sure how much the halibut helped by not, well, it's being relatively structured in their movement, shall we say, but it's still a very nice summary, and I agree with Sean that you know, it would aid a lot of the discussions about uncertainty in model and movement and all these kinds of things.
This is Mark, and I would like to second Sean's affirmative response. I have been waiting 6 years for this picture.
Took us that long
Thank
to
you
find
very,
Europe.
very much.
But yeah, when I look at that, I see all of the papers and all of the data underneath each of those points in each of those blobs. It'd just be a matter of, like I say, making it live, animating it, making it pop up when you put the cursor over it.
Along those lines, if you're doing kind of a data map, it would be nice to have in there sort of like what's the quality or what can you know from that data. So where do you have yearly estimates of movement? Where do you have some tags, but there are some problems with survey design historically, like with like the 1960s trawl survey tags and I lost it. Yeah, and then maybe that makes it easier to define the gaps too. Oh, I guess like for what ages do you have tags? So did it come from fish being tagged on the set line survey, or did it come from fish being tagged on a trawl survey or some other type of setup? Just a little bit more detail about not only where do you have data, but where do you have data that you can tell something from quantitatively and for what ages. And then my other comment was, it seems to me like there's also some seasonal movement that goes between regulatory areas and or biological regions. I'm not on this, but just from memory.
Yeah.
And so it would be interesting, I think, to mark seasonal movements between, especially between biological regions, but also maybe between regulatory areas and when those seasons are.
What's your definition of a nursery ground? And, you know, I see whole areas up there that go from Cook Inlet down Kodiak Island, between Kodiak Island and Katmai, or it's green. There's no arrows going there. I mean, so there. Generally, the whole thing is really nice, but some pieces of it I'm not actually seeing coming together for me.
So what I was considering is around between 0 and 2 years old. So that would be my kind of nursery area, because then from 2 years old, juveniles start moving again, and that's, you know, so where the larvae settle mostly, and so yeah, I guess I could have gone very precise and try to look at the literature and get the location exact where they've been reported, but in general they tend to agree that, for example, on the central west part of the Gulf of Alaska, the coast is a good nursery ground, while on the eastern bit they tend to be very, very little, you know, up to 2 years old. They don't really find many. And the Bering Sea, the whole shelf is kind of shallow, so it's a potential. And they had some plankton studies there, and I mean the shape of my blob actually tried to represent that study exactly. So surely, I mean, it can be improved. I guess also it's a question of how detailed we want to go for this kind of thing. But I guess we could also have different option depending on the public and the target we.
How long are they pelagically dispersing the larval?
6 months, 5-6 months.
I don't think we've done any explicit pelagic larval duration studies, like daily proliferates or anything like that.
There's been
but-
a few that have kind of looked at it, and it's estimated 5 to 7 months. So
Really?
for the modeling that we've been doing for the larval infection modeling, I believe, chose 184 days because it just worked with how she planted the seeds. So yeah, it's about 6 months.
So when you're building this operating model, what's going to be the, say, recruitment age in that? Are you actually going to try to model larval dispersal and that sort of thing? Or are you just going to say, here's the spawning ground, here's the spawning areas, and here's the recruitment distribution on average from all these processes?
It's a good point. We are going to model some recruitment distribution, and there's going to be variability to that. And then I imagine ages 0 to 2 just aren't going to move a whole lot, but then we'll have to, Ian's data document from the annual meeting has some specified or estimated, not estimated, but I don't know what the right term is, but it has some movement probabilities at age from about age 2 and up, based on data and inferring assumptions. So yeah, it's going to be and a lot of assumptions and decisions to be made yet.
So you want to go out and you want to identify spatial genetic structure. How would you use this to develop hypotheses about where Joseph and his crew could go out and sample to be able to really get the best idea of how the population is structured and gene flow?
I'll leave that up to Joseph.
Yeah, I'm just gonna tell him what I know and ask him what I should.
Point to that box with no arrows in or out.
Exactly.
And we say, tell us if that's really isolated, because we don't have any tagging that suggests otherwise.
Exactly.
And that's exactly what they're planning to do.
Yeah, but I think the idea of putting data associated with this to really identify the gaps, I think you said that would be really useful. And then thinking hard about where there are current gaps, and here, as Dave suggested, we do have some indication of connectivity out in the western areas, you know, just trying to fill in the plot a bit more. But I suppose it would take some more thinking to come up with hypotheses based on what we know about these pathways and movement that would then feed into Joseph. And I think that would be a good segue into your presentation of our linking of these research items. Unfortunately, I have 2 more slides to go.
And
But
Gary's
just
comment
briefly,
about-
I think it demonstrates the importance of defining where we don't have data versus where there is no movement. You can't tell that
Yes.
from this plot.
Sure.
You know, you could make the argument there's lots of data, but there is no movement. That to some degree might actually be addressed by sort of automating it with that
Right.
on there. But it is important to distinguish those negatives from each other.
So yeah, this figure is currently in development, and Pierre has done a fantastic job just summarizing decades of research and decades of understanding on this, and been working very closely with the biological research branch. So it's I'm really happy to see this progress. And then just to let everybody know that Pierre is working along with the research branch on writing a review paper on migration of Pacific halibut. We think that's just timely right now. We'll use this figure and Pierre's presentation skills at the MSAP to to give them an overview of how it works and then how that fits into the operating model as well.
Just as a suggestion, if you're going to present this at MSAB or annual meeting or whatever, I would do it in layers.
Yeah.
You know, start with the spawning blobs and then
Yeah,
that would be
absolutely.
really cool. I think people would really like that.
And I think there is a new feature in QGIS that allows you to print a PDF, but having the layers active actually. So you could turn on and off the layers within a PDF. So that could actually help that.
But I think as Dave suggested, having this on a website with those layers being chosen and interactive would be really neat. And then maybe that's. So, yeah. I think, well, I don't know, we'll talk about linkages with our MSE objectives or MSE research priorities and the research stuff later, or actually I have one slide showing some stuff on that, but shall we move on?
Yep.
Thanks, Pierre, for that. That is great. So there's been a number of years the SRB has been talking about linking research priorities with the MSE and the assessment, which has been great. And Pierre and I have been thinking about that a lot and identifying our research needs basically for the MSE. And we started actually realizing that we have our own feedback within the MSE process of identifying these needs. And so we've come up with this figure for now. This is really draft form. But it's basically pointing things out like we define objectives which actually identify how we need to structure the operating model. And the structure of that operating model might identify some of the research and the needs that we have, such as estimates of movement between regions or even areas, for example. So objectives feed into a lot into the development of research ideas and needs, but it also is used in the MSE process as well. The science informs a lot of these research needs, and then that gets fed through the MSE process, this closed loop simulation. We do an MSE, which then the iterative process feeds back to objectives, which can then identify more research needs, for example. But that MSE process also highlights where we actually have new research needs and priorities as well, and that can feed right back into this process. And then we just note that 2021 is going to be our first round of MSE here and spit out an actual application. I suppose there might be an arrow coming back. So we've been thinking about research priorities. We haven't identified anything here, but there are some identified in the document that Joseph will present shortly. The final bit in this presentation is just a reminder of the program of work. So this is a Gantt chart with the different tasks along here, seven basic tasks with subtasks within, showing in green or dark blue that we're actively working on something. In purple is when there would be an MSAB or SRB review of that concept. And then in red or orange red is when we'll be delivering results on those. So for example, with objectives, we're reviewing that now. We're currently at about this point in time. And you see that we were reviewing objectives, reviewing management procedures, and those two concepts will be presented at the annual meeting coming up in February. We'll continue identifying objectives for review in spring. We're developing the operating model. We've talked a little bit about that in the closed loop simulation framework for review in the spring. And then we'll be running the simulations to evaluate scale and distribution, basically really leading up into spring for final delivery of results in January 2021. What's not noted on this Gantt chart, which commissioners have actually suggested they put on, is the peer review, the external peer review of the MSE, which that I think I sent out the terms of reference yesterday for that, or the announcement. And that peer review would occur basically right before this purple line. So hopefully we can get someone external to come in, take a look at what we're doing, see some really preliminary results, make some suggestions, maybe actually collaborate with us. I'm not sure if that's yeah, depending on how the person is, make suggestions. We implement those suggestions. They come back, review them again right before this purple line, right before the SRB sees them. And that would be sort of the external benchmark review or bench review of the MSE going forward to be looked at by the SRB and then evaluated by the MSAB for presentation in 2021. So I'll put another line on here for the review, showing the points in time there and there. That's all that I have.
Alan, did they also ask for the economist, or was that something else entirely? It was only a week ago, but still.
Yeah, no, I don't remember that one. We talked about that as potentially how they might be integrated into the MSE, especially with the MEY concept.
So I'm just thinking about maybe you want to put it up there, the terms of reference for the MSE review. I think one of the things you're gonna have to be really careful about who you get, I think.
Yeah.
Because there are lots of people who do kind of benchtop MSEs, like they do simulations and stuff, but that's not what you need. You know, you're going to need somebody who's actually has kind of been taken the lead in seeing an MSE through to a procedure that's been applied in practice. And that's a big leap, that final step of actually adopting a procedure and using it.
We have been thinking the same thing, and that there isn't a large pool of people.
And you're already on this panel.
You've got two right here.
I know.
People are in the room.
Half your candidate list.
That's why we really want to get this process started as soon as possible to find somebody.
Does it have to be someone who's not in the room?
Well, we do want it to be external from this process.
From the SRB process?
You got to look at somebody like Doug Butterworth. Big possibility.
Yeah. Possibly. Nakomi Bentley might be somebody good.
Andre?
Yeah. John DeRoba, yeah, he's done hearing stuff. Yeah, it's a small pool of people, and we realize that.
Yeah, I mean, part of it,
Sorry, the terms of reference is not on this computer, but I can get it there if you need it there. But I guess my question back to you then is, if we are unable in the short amount of time that we have find somebody from the small pool of people, do you think that we can get something out of a review of the MSE from somebody that hasn't been intimately involved with the entire process? If that's the case, should we modify the terms of reference in any way?
well, you'd have to have it written up. You know, like the stock assessment's got this trail, right? This paper trail of documents and everything that a reviewer can work with. In the MSE, you don't. You've got some, but it's, you know, there's a lot that even we get in these presentations that isn't, you know, totally clear in any documentation. So
we are, as we develop the technical document, we hope that is almost a one-stop place to go that will have the real technical details of the operating model, the specifications and the assumptions we're making, how we're doing projections and things like that. So we're really hoping that we can be writing that technical document as the current snapshot of the MSE with a description of all the past assumptions and how we're doing things in it as well. Might be useful.
Yeah, I mean, the modeling details may not be as important as, you know, how you actually go about doing it. And you start doing your simulations when you, it's those next couple of steps. Like anybody can do a simulation.
Yep.
Anybody can review a model.
Yep.
But getting a stakeholder group like Halibut to adopt a single procedure, you know, it's a fairly big deal.
Yeah, and I would agree with you. We are looking for somebody that can help us in the process. And that's why we want them at 2 different periods in time. When we're, you know, for a reviewer to come in at the end of this and then just say, well, you could have done this, this, and that isn't going to be as useful as them coming in earlier in the process and saying, here's some ideas, here's some things you can do, going away trying to implement those and trying to make it a better process to actually get applied and implemented. Trying to bring
Somebody
those
who's
up.
been involved in other RFMOs that it's kind of written like simulation.
This is the sort of announcement or advertisement, draft announcement for the peer review, the MSE peer review. With principal duties here. And project deliverables is another thing. So I'm not sure if there's something specific you wanted to see.
Do you want to have assist in there?
Well, that's
Then it becomes a developer, not a reviewer.
That's what I'm wondering is how much do we want to keep the reviewer independent of the development? And
They can advise, but I don't know about assist.
okay.
And I think that's sort of the, we've gone back and forward on that. Originally, it was just to get somebody in to assist with the development, but in the end, we got Pierre and Steve. And so it's slowly being changed to review and advise, but that's the last remaining assist. You can certainly change.
Yeah, I like the idea of 2 stages. So you don't get blindsided in the end, though you did it all wrong. But hopefully we're here to help that.
But the 2 stages you're assuming to be the same person. Would you
Yes.
necessarily need the same person?
I'm
Just
hoping to
because
have
the
the
pool will
same.
be quite different for those 2 elements.
I'm hoping to have the same person just for that continuity as well as them having a better feel for what we're doing in the initial parts of it.
And also a bit more trust as well from commissioners, MSAB, and probably yourselves, seeing the same person go through.
Sorry, doesn't say anywhere about going to an MSAB meeting?
So that was something that we considered when we originally wrote this. The idea was to have somebody come in this October, and go to MSAB meeting. It's obviously too late for that. So Dave and I have had discussions about, well, let's really keep this as an external review, which is why some of these words are being changed. And one thing I've been thinking is getting an external reviewer that going to an MSAB meeting would be interesting for them, but it could also be a time suck as well, because that's potentially 4 days of the reviewer just spent watching us haggle over objectives, which they might be able to help speed up that process. But we felt time would be better well spent just sitting down with Pierre and me and Dave and Ian and in the office and really digging into what they want to dig into. I would definitely encourage them to participate. They could do it online if they're not local. or to come to an MSAT meeting. We could work out those details, but I don't see it as required.
I mean,
She feel different.
I get, there's a problem, I think, would be if you have somebody who doesn't know anything about IPHC, you know, might come from another RFMO, and if they don't understand kind of what you guys deal with, then there'd be a benefit, I think, to going to something to know about the stakeholders and know about the process.
Right.
I think it'd be hard otherwise. That said, maybe there's the pool of people know enough about IPHC already that you could either put it in the terms of reference that has some understanding about the system that management puts here, but.
Would it, we originally did have that in there, I think, and I removed it, but
Which component, sorry?
MSAP, not participating,
Yeah.
but at least sitting in on an MSAP meeting. Because they're webcast, they could do it remotely.
That's what I sort of lean towards, if you wanted to include that. It's just join, like Mark's joining now.
Yeah, seems like it'd be useful to have that background, other than
Yeah.
this is what we're doing for the models, you know, you need to have some understanding of who it's for.
Yeah, it might also be worthwhile to have said person attend part of the annual meeting to see how the MSC fits in with the overall process.
That would be this upcoming February meeting. That would be the only opportunity to get a review before the 2021 annual meeting. So we'd have to get on this pretty quick.
So the good news is we record and all of these meetings, and they're all available on the website via YouTube links, so they can go back and listen in to any meeting that they'd like. Maybe that would be the way to do it for the annual meeting. They can just go and listen to the MSE presentation section for the last 3 years.
And discussion, yeah.
3 hours.
We could
That
extract.
sounds like a great idea. Yeah.
It seems like, you know, I mean, of this decision
I would
of,
raise my rates if I had to.
Sorry, does
Like-
that carry? Or?
I was just gonna say, whether,
Double time for this.
whether you have the person come to the MSAB meeting or not, or listen in on it, I mean, do you want a review of like, you know, there's this distinction drawn between a closed loop simulation model and MSE process, right? And I think that, you know, we tend to think of like the modeling as the thing that needs to be reviewed, but like, I mean, there's a lot of details and sort of best practices concepts for how you interact with the stakeholders and do that piece of things. And it seems like a pretty good opportunity to have a discussion about how, I mean, I think it works well over here, but I think it's just an opportunity to have a discussion about how all that works and know how it's, you know, maybe there's something to be learned about how it's been done in another place that we haven't heard already, or so if you're really reviewing the MSE, I would think that you would need to review both pieces of it. Otherwise, maybe it's a review of the closed loop simulation model.
Right. Model and process.
Yeah, I mean, I think the challenge for you guys is the stakeholder, the complexity of the stakeholder group. And from that point of view, you might need somebody who's actually knows something about MSE, but is more in the lines of a structured decision-making kind of background. Because that's going to be the critical step is getting this to completion.
Mm-hmm.
There are people, there's a group out of Vancouver called Compass Decision. Do you guys have that stuff?
I think they
Rings a bell.
were they our facilitator?
Assessment facilitator?
Yeah, they're your facilitator, yeah. They do lots of, and they facilitate these kinds of things because they're good at it.
Yeah.
And maybe
Didn't
one of
they work
those,
with our
maybe one of them.
stakeholders?
You could talk to them if they'd be interested in.
But they're not very technical.
That's right. They wouldn't have the technical background, but we've got lots of technical background here.
Right, exactly. That's a good point. I
It's
suppose
like Jerry's
another.
saying, like, are you reviewing the technical aspects or are you reviewing the process?
Well, just to chime in there, we've already reviewed the process, however you want to say it, from Kevin Stokes' science review. So he's already stepped through, at least at a cursory level. So it's how much deeper do we actually want an external reviewer to get in there and have a look at the process and whether we've been thorough enough. Probably don't really. I mean, that's really something that we've been doing over time, and the commission reviews annually. The MSAB members all comment on whether they're happy with the process. So I'm not concerned so much about that component. It's more about similar with the stock assessment peer review, where the commissioners are suggesting they want somebody external to come in and have a thorough look at it with a fresh set of eyes, make sure that everything that's being done is rigorous. And then as part of that, you could also check off on some of those other process elements. Otherwise, as you say, I mean, there's more than enough expertise that has been contributing to this process over the last couple of years. Otherwise, you'd have to ask the question, why do it at all, I think, which is also a valid question to ask.
Yeah.
Yeah, I would agree. And
At this
maybe,
particular stage.
yeah. And then potentially after 2021, if whatever happens at that point, maybe then we can take a more holistic look at the process that we've embarked on historically to get to that point and how it could be improved in the future if this is to continue on. That's good ideas. I was going to say also it might be useful to have the reviewer participate or at least join in an MSAB meeting, be able to introduce them to the MSAB, and the MSAB would feel comfortable that they are reviewing the MSC and have a little bit more familiarity with the reviewer at least. Okay. Anything else on MSC? I'll bring up the.
And that's one of those budget points as well, which automatically starts to have a play.
Sorry.
If we want to start to bring somebody to annual meetings and MSAB meetings and they're based on the other side of the world. Just as an example.
Sorry for missing the end of it, but I had a couple of things, and it might be, again, not remembering it's been covered, but in the MSAB activities and the MSC planning, there's two things I'm going to ask about, like what we call robustness tests. It's like, might be kind of outside what kind of the mainstream models might look like, but they're kind of exceptional that, oh, all the fish go to the Aleutian Islands and stay there, kind of a thing. Of course, those types of issues. And the other one is just for part of the procedure, like if down the road they adopt something, maybe it's the SPR rate of 46% or whatever, and something arises that says, oh, we don't need it that bad, or there, what I'm getting at is if there's exceptional circumstances. Those are two things that are pretty commonly part of the planning process, and maybe it's covered in MSAB discussions well enough. But
yeah, we've talked a lot. The first question on robustness, we've talked a lot with the MSAB about defining variability, and we've identified defining variability as a number of things, just the parameter uncertainty in the model, defining scenarios, which are potential reasonable hypotheses that we should introduce. And that would, movement is a great example. Movement could work like this. Another scenario is movement works like this. We can't separate the hypotheses, but we're going to put them in. And that could be implemented as different operating models, for example. And then the robustness tests in the MSAB, we've been calling them more sensitivities, and looking at those extreme cases outside, less likely than a scenario, but we just want to see how it looks and make sure that it's robust to those sorts of things. And I'm sure with the sensitivities, those are yet to be defined. We'll be working with the MSAB on those, but they would be probably, you know, it might be hard to start delineating between scenario and sensitivity, but we're going to have to draw a line somewhere. When I attended the tuna MSC meeting last summer, that was really informative. I was really influenced by the way by what they were talking about with these robustness tests, and then your second point on these exceptional circumstances. And with that, once this MSD is presented and harvest policy put into place, that, you know, we're not going to give up on the assessment. And I think the assessment will be our annual check-in, whether that's an update or a full or however that works. But I think we'll have a harvest policy in place where we don't need to have this full blown out assessment every year, but a check-in, make sure everything's going smoothly. And then whatever year, a more full assessment. So that's where the process, I think, would come in that sense. We haven't really talked to the MSAB about that process of identifying exceptional circumstances, but we've talked a lot about robustness tests.
Which is a little bit odd because the MSAB's not super technical, are they? Kind of robustness tests.
Yeah.
I mean, I consider, or I'm thinking about the operating model, which is like what are plausible biological hypotheses, which.
Yeah, the MSAB is an interesting group of people. For example, they've been requesting the last number of meetings to get a presentation on movement and stuff like that. They want this biological understanding. They want to be informed at least about it. So Pierre is going to present that figure. Did you miss that presentation? It was really good, by the way. The movement figure.
That's part of I did say I really like the schematic. Now you just have to put some numbers in the arrows and it'll be.
Yeah, exactly. You go ahead and do that.
Some numbers in the air.
But
free arrow, you're gonna be able to click on it and see the data.
Yeah, that's right.
That's right, where it came from.
But the MSAB has been very interested in those sorts of things. But we have been focused on a management procedure rather than a management procedure and a process outside of that as well. But it's a good point. It's probably something to mention to them and the commission, so they're aware of it.
So one of the things that I've picked up from dealing with the tuna work is tuning procedures so they all meet a certain criterion, which takes away one of the dimensions. For instance, what we're doing now for sablefish is all the procedures are tuned to meet a BMSY objective by a certain year on the median.
Right.
So what happens is if you didn't do that, then you'd say, oh, well, these procedures have, you know, they differ in annual catch by 200 tons to 150 tons, but they also differ on that probability of meeting that objective. So by tuning them all to meet the objective, you spread them out in terms of their other performance metrics. You actually see how they differ in terms of yield and stuff.
And so how are they tuned?
So each procedure has to satisfy a specific criteria.
Okay, and so either procedures are eliminated or the procedures modified to meet that.
They have to, yeah. That's kind of, and the nice part about it is that you get early involvement and buy-in. You just go to the commissioners and say, give us an objective you all want and can agree on. And it doesn't have to be how you get there, you know, that'll be a secondary thing, but it could be things like, you know, the level of stock you want it to be, you know, kind of one of your objective slides. And then there might be other ones like, we don't want the DAC to change by more than some percentage per year. You know, those are and within that, develop a procedure that performs well or satisfies those, and then kind of the robustness tests come in to see how robust they are to shit happening.
So it becomes less of a shotgun approach and evaluation of a bunch of management procedure. It becomes to developing a management procedure to meet those objectives and then testing it.
Like you showed, when you showed your results for the 3 different harvest control rules, well, they all had different profiles, those probability plots. That's because some of the more conservative ones that have the threshold shifted to a high biomass, you could have fished at a higher rate, right? and achieve the same objective. So that will bring them all back to a common objective. And then you'll say, oh yeah, that one actually, you get more yield out of that one. While it continues to meet the same core objectives that they're interested in.
Right. So that tuning objective, I don't know if that's what it's called, but that tuning objective would have to be defined as meeting something by a certain time, or?
Well, that's,
Depends.
can be.
Yeah, it could be.
It could be, don't let CPUE drop by half of what it is now with a 20% probability. I don't, something in the next 10
You
years.
don't want us to have it depend on a small probability. It should be something that's a fairly robust statistic.
Okay.
So I play devil's advocate and say, if Alan goes back to the MSAB and says, you guys need a whole new objective that you're now going to use as the primary tuning driver, they're going to cream them at the next meeting.
They just need to pick one of the ones they already have.
It's not a whole new one.
But they're already ranked, so they already don't pass go on each objective unless they meet the one above it.
Yeah, but the one, for instance, your top objective, which was biomass stays above 20% of B0, that's met 100% of the time.
Yeah. And then.
And
So
the
then
criterion is 5%, right? So what you could do is say, okay, tune every procedure so it hits 5%.
Right.
Why would you go better than that if the objective is 5%? I'm not advocating doing that because it's a small probability that you would not like to mess with. But
It could help in this distribution thing. The problem we ran into in the last round of MSE was all management procedures met that objective, and then the next objective was the variability one of 15%, not exceeding 15%. And then none of the management procedures that were proposed met that one. And so we had to go back and develop more management procedures. That was the issue I ran into presenting this time last year to the SRB, is I realized that was happening and I didn't have any results to show. But that's the case, and that's why we want to have 2 rounds of results. So we're looking to have results next May and June for initial review, but identifying an objective. I've put some thought into that. I might actually contact you in the next few months to get a little bit more.
There's a way around that consideration. I mean, Anne-Marie and I were talking at lunch about it in many ways, that you don't assign that criterion or the probability to it. You just say that's what the objective, and then for your different management procedures, you just show these are the values you end up with. So then you don't have to consider them nested in a way. They could look at different things and actually say, well, okay, we thought we all wanted this, but actually that, we're willing to forgo, I don't know, the 2 percentage points that, we're missing it by. It's an acceptance of risk that you're asking. So you're asking them for trade-offs. So if you only show them half the picture of the trade-off, that's, I think, how you get yourself into the cul-de-sac, rather than because you've nested it, so you've eliminated everything else. And you could have been very close to it, and maybe even in a different simulation, you wouldn't have been beyond it. So that precision estimate, I think, is something that you should let float in this.
I think for certain objectives, we can definitely define what I'm calling the tolerance, like the B limit, the 20%. Not
for the biological, that's fine, yeah.
But for the fishery ones, I totally agree, and that was exactly what happened. Is in some of the management procedures, the AAV came out to 16%, and their cutoff was 15%. So I was like, well, that's what we defined. Can't see the management procedure, but then we actually looked at it, and it's like, well, that one performs okay, and we're willing to accept that.
Yeah, and I think that's kind of a more sensible approach to give them the option, because a lot of times they have perceptions of how these things work, or how the stock works, or how the fishery works, and they're actually surprised by the results.
Yeah.
So because they don't know the underlying dynamics. Well, let's face it, we don't actually understand all the underlying dynamics. We get surprised by these things, so to expect them to sort of have that idea.
Yeah, that's a good point.
But going back to the scenarios of biological realism that Jim mentioned, I actually find that there's an entire realm of this MSE work which hasn't really been mentioned and kind of actually feeds back into the science directive element. Is, you know, you can use this to evaluate the sensitivity to certain data gaps or different hypotheses and stuff. So you can actually use this tool on the level of the management metrics. So in other words, you say, well, once you clear up this uncertainty where we're having large variability, actually you'll be able to increase your yield by X%. That gives a trade-off that actually then says, is it worthwhile putting money in here? Now, it's probably going to be ongoing work and continued work, but I think it is the way that you can integrate the research program and the assessment program into a continual, well, a more coherent picture. And I think that's will make a lot of the other decisions a lot easier.
Yeah, I would agree. Right now, we have a very focused directive to work on, which is why we're not doing that. But I've done that in just for other species.
Okay. Any other comments on this? Now we're back to our old habits of getting a little behind. Let's start up with the biological program. We have a scheduled break at 3:30.
Yeah, Alan, I was in your office for my call and I
Oh,
flipped
boy.
through those 1968 simulation model and that was,
The southward,
yeah. It's
The
pretty
original
cool.
MSC, that's the first MSC.
the figures in there, the like the whole.
There's some really nice figures. I was thinking you should just pull those out.
Yeah, that's a cool one. He did it. That was his, I think, dissertation at UW. SAF. Yeah.
Interesting. It's the same year that Walter published his simulation model.
Oh, was it?
Okay. This is, I'm going to start my presentation with the request from the SRB in the last June meeting that is related to the presentation of an integrated set of future research priorities. The initial recommendation was that this was presented at the end of the research program, but with discussions with Alan, Ian, and Kira, we thought that this was probably more appropriate at this time, so that you could see how we see that integration taking place. So what we're going to be presenting is first, very briefly, a revised diagram of how we see the interaction between the IPHC Biological Research Program and IPHC Management Program, specifically stock assessment, MSC, and then the other inputs that will fit in, as you can see. And then I'll move on to show that table of research priorities, which we circulated yesterday for your review. So this is the revised integration diagram, and it's a very simple one in which we can actually see that within the IP Secretariat, the activities of the biological and ecological or ecosystem research are actually intimately integrated with stock assessment and MSC. This bidirectional arrow means that there's actually communication back and forth between those two components of the Secretariat. And what we'll see here is how research priorities that are originated from stock assessment and MSC are actually influencing and directing research activities from the biological and ecosystem science program. What you've seen in the past, and I will again show it a little later, is how all the research activities that we conduct, whether they are immediately of application into stock assessment or MSC or not, then have management implications, direct or future implications. So we've incorporated here another box in which obviously the biological and ecosystem science research program also conducts basic research and applied research towards basic understanding on biological processes that may not have, again, a direct impact on stock assessment or MSC at this time, but that can potentially have impacts. The input towards Secretariat actually comes also from outside in the form of recommendations by commissioners, and importantly from IPHC subsidiary bodies. The SRB is one, but we also have the RAP, the Research Advisory Board, that provides input more related to industry-derived questions. So what you'll see next is really our first attempt really at refining those research priorities and to better show that integration between the biological research and management. So if you allow me to draw the table, which is on a Word format. So here is the table in the format that was requested by the SRB in the June meeting with research priorities by category, ranked. And what we've done is to rank the first three categories in order of importance, but we've also indicated some other categories that are of interest, and those are unranked. The product, the justification, the biological research area that this research priorities are related to, the timing, whether this is whether they're medium, long term, or whether they actually have a specific date, and the current progress. So if you have taken a look at this table, and I'm not going to go through the entire one, you'll see that the categories are in four broad areas. The first one is stock assessment. Stock assessment has three different categories: biological inputs, assessment, data collection and processing, and the third one is technical development. The second broad area is MSC, and MSC has, again, three different categories. One is biological understanding, the second one is data, and the third one is technical. The fourth broad area represents the basic, or also called theoretical, but I'd rather prefer to use the term basic, biological research. Just to distinguish theoretical from experimental, because in sometimes those two terms are a little confused. And here I've also ranked some of those biological research categories that will eventually yield fruit that will be of use for stock assessment and MSC. And lastly, the category that represents the advisory and stakeholder inputs. Those are mostly derived by the Research Advisory Board in that case. And here we've listed the three of the recommendations that the Research Advisory Board has come up over the last couple of years. Without wanting to go into a lot of detail, every single of this categories, again, has three ranked, what do we call those? three rank categories with specific products. And throughout my presentation, I will be drawing back on the research recommendations as we move along. I'd like to see if there's any feedback from SRB members regarding this table, knowing that this is our first attempt to really synthesize that those research priorities originating from stock assessment and MSC into the research program.
Yeah, the one thing that strikes me is it's still separated into those separate components. We don't see a lot of those things, whether it's maturity and skip spawning, that ultimately ends up feeding into the stock assessment process where he's modeled some of those things. So all those linkages, I struggle to see. There's still separate elements, and all you can say is there's something here that has something to do with the other elements rather than specifically being able to link those. I don't know if it's possible, but I was certainly not. I was expecting a single list that wasn't kind of separating it into the three areas, but combining, this is done and we're doing basic research, and the thing we're doing is, looking at maturity that's relevant here, and it's not important for the MSC. Kind of doing it that way around. In many ways, it may just be transposing the table, and it may be that in the end there is actually no overlap between any of them, and then that way you just have a single line or a single entry for each of the three research topics. That's how I was kind of envisioning it, that you didn't end up with this somewhat artificial segregation into those research topics, which is necessary from a budgetary perspective. It doesn't help in seeing the flow of information and the influence of that information in terms of the other elements.
This was meant to be complementary to the other table that I'll show in a minute, in which you've seen previously, in which every specific research output has named the specific inputs into stock assessment and MSC in a table format. Obviously, there's a lot of information there that is not reflected on the table, but
challenge we ran into was that you asked for ranked or prioritized items, and we were unable to prioritize, for example, technical development aspects of the assessment against basic biological understanding. And so we had to have categories to rank inside because we weren't, who's to say which of those things is a higher priority.
I mean, I think this is great. I think I can see how it would be really helpful for getting organized and for research planning. Probably the biggest benefit of this is that you guys sat down and went through and did it. Probably forced you to think about things like ranking and like you just said, right? You can't rank across, you got to rank within, and then you can even see where it was like, well, why bother ranking anything below 3 or above 3, whatever you want to call it. So I think this is really helpful as a planning tool and a communication tool for seeing the big picture, kind of what's in it. And so I just look forward to seeing the next table about how
this is Mark. I agree. I think it's very valuable to be all the time asking yourselves, why am I doing this? Have we ever discussed Hamming's paper called You and Your Research? Does that sound familiar to anybody?
Doesn't ring a bell.
Okay. I put it in the SRB share Dropbox. And how about Stokes's book called Pasteur's Quadrant?
Oh, yeah.
Yes. You shared that one with us.
You mentioned that, yeah.
Yeah, okay. So I think this is a great step in the right direction.
We tried, when given this task, we went through a lot of iterations of different formats. Dave helped us see a few things as well. And was much more difficult than I imagined it to be, but I think we've ended up at a good place. And Mark, originally I thought, let's try to link a lot of these back to Pasteur's quadrant. And we tried that at first and it didn't really come out. And so we abandoned that idea, but we've settled on this idea. And one thing we were talking about the other day is I think this table might be useful to be interactive as well, where it has certain hyperlinks on it. For example, you look, estimate connectivity with Western Pacific Russian waters, and then there's certain links like genetics and genomics, and that links to a page on that research. And so you can sort of go back and forth between broad views, specific views, and things like that. So that's where at least I've been thinking we're heading with this.
If there were layers, it would be useful to get into the details on methodology, right? I mean, I guess that reproduction, genetics, genomics, and these are sort of the how-to, but it doesn't really get into the real details. What are the parameters that you're going to be estimating, those types of things?
And that's where we're thinking the hyperlink would then take you to that page, and then you'd be able to dig into it and say, oh, they're doing this study on, you know, collecting ovaries from the survey, and that's going to lead to, and then it comes back to, oh, that's going to improve estimates of maturity, right? And so it's not really, I think what I'm seeing is not a one-way table. There's really, it's a two-way table, and you can go back and forth between things.
Yeah, you can see in the third column there as well, you have well, why is it important to do it, right? But if you have why is it important and the parameters that the research is going to do that, then you could have a layer of basically saying this is how we can put it in the model, right?
Yeah, I think even in the progress, you could that's what you're getting at, but in the progress column, you could have those links, because maybe you have working papers along the way. Because, you know, things are ongoing, but it doesn't mean you're just aiming to produce, say, one paper, right? It could be literally ongoing.
The other thing we discussed was that it might be nice to keep things, even when we have something that's completed, to actually keep it in the table so it's documented. So people can see, look, here's the project that was done and it's still, you know, still visible.
It's always nice.
Because otherwise it just looks like we haven't got anything done.
Yeah.
It's you could actually, and that would help the sort of idea I had for this that appears to be difficult to do, but you could have, for example, a paper, you know, an SRB paper or a report that you did to look at the skip spawning element and the magnitude of it that could be there, then it would be immediately clear why you're doing that study and where it can have an impact. So you get both, and maybe you get the flow that way through. So when you have done anything on these things, then you can connect it to the basis for wanting to do that research.
Yeah, if I could just sort of complement all of that and go back to what Alan was saying as well in terms of the website and how we're moving forward with sort of documenting and communicating what we're doing and why and linking it. At the moment, Alan, I don't know if you could bring up the science and research page on the website. It has the core areas that we're working on already. And so what we need to do is find a way, once we're settled on this table format, is to incorporate it probably in this sort of location on a website, where it's then, as you say, linked to historical research that we've done. So we have that as a permanent record, and then also sort of the ongoing and future projects. And so at the moment, each of them are broken down into particular areas. So if you scroll down, you'll see a couple of the core areas. You have the stock assessment, MSE, survey, and then the research. So we'd be looking at linking all those, but if you click on the research one, the biological, and then you have the same sort of thing again, where it links to the 5-year research plan at the moment, the core areas. If you scroll down again, it then has the each of those core areas that are accessible and somewhat interactive. And if you were just to click on one of those, it doesn't matter which one, some of them are very static, others are being developed to be more interactive. And again, here you have the details of sort of what we do, how we do, and the idea is to expand those into include what's been produced research-wise, why we did it, and make it very much that interactive. So we've already started to head down that way, but I think this idea of having right at the start of that page, the science and research, something that outlines the whole picture and why we're doing it, and then is linked to all of this sort of historical research as well as future or ongoing projects, is going to be a fantastic tool. But it will take us some time.
No rush. Okay, let's continue.
Okay, so this now begins the presentation on the update of biological and ecosystem science research. This is what I'm going to be covering over the next 30 minutes. So hopefully we can still take a break at 3:30. I'm going to start with just a brief description of the 5-year research program and the implications, and then follow up on the progress on ongoing research projects. Now we have the 5-year biological and ecosystem science research plan up in our website. It's a document that you can check. It describes the work that is being contemplated within the next 5 years on the 5 research areas that are contemplated in this plan. The first one is migration, and this one has as its main objectives improved understanding of migration throughout all life stages. The management implications are in stock distribution and regional management mostly. The second area on reproduction, that has as its main objectives provide information on sex ratios of commercial landings and to improve maturity estimates, and the management implications are related to female stock spawning biomass estimations. The third area on growth, our main objective is to improve our understanding of factors that are responsible for changes in size and age, and for developing tools for monitoring growth and physiological condition in the Pacific halibut fishery. Management implications are related mostly to biomass estimates. The fourth research area is discard mortality rates and discard survival, and obviously our main objective here is to provide estimates of DMRs in the directed long line as well as in the guided recreational fishery. Management implications are related to discard mortality estimates, obviously. And the last research area, genetics and genomics, its main objective is to improve the understanding of the genetic structure of population, but we're also aiming at providing genomic tools with which to conduct the studies, and that is namely the sequencing of the Pacific halibut genome. The management implications are many. Stock distribution and local adaptation are two important ones. This is the table that I was referring to before. This is the table that you've seen. This starts from research areas, research outputs, and how those specifically link to inputs into stock assessment and MSC. So if you go from the left to the right, in the left we have the two columns on the biological research. On the far left column is the 5 research areas. The second column is the research outcomes with specifics on what are we studying. And the third column is why are these research outcomes relevant for stock assessment. And you can see that for larval distribution, the relevant for stock assessment is related to geographical selectivity, stock distribution. And then on the far right column, you see how those, what are the inputs to stock assessment and MSC processes. And just to give you one example of how we see that being integrated, if we take the information on sex ratio of commercial landings that stems from the research area and reproduction, and you can see it right there as one of the research outcomes, then this provides an input into stock assessment, sex ratio at age, that is important for the spawning biomass scale and trend, but also represents an input into the MSC process. Again, sex ratio at age that fits into the operating model. This you've seen before as well. This is the temporal progression of this research activities, highlighting 3 different research areas, migration on the top, and you can see here in bright yellow, the periods of data analysis. And here in orange, we have the periods of data synthesis that I'll go into in just a little bit. You can see where also we expect some information useful for stock assessment and MSC, and these dates are obviously shifting a little bit depending on how well the research goes. The second example of research area is reproduction, and here you have stock assessment and MSC inputs on the sex ratio, for instance, which are one of the first ones. And a third example of a research area and how sample collection, data analysis, and data synthesis, and finally incorporation of that information into stock assessment and MSC takes place. This is obviously in relation to the proposal for hiring a life history modeler or evolutionary ecologist, we can call it that way as well, that was sent out to you for input, and thank you for your input. So we'll be revising that position description and announcement based on your recommendations, and we hope to present this to our commissioners in the upcoming meeting. So this is a position that we envision probably having late 2020. Some of this data synthesis is already being conducted, as I'll explain in a minute, and that is related to the one on larval distribution. But let me get that in a minute. So I'll go through the 5 research areas, and as I said before, I'll begin each one of the research areas highlighting the research priorities that you've seen in the previous table that relate to this particular research area. So for instance, on migration and distribution, I can highlight here 2 categories, one for assessment regarding biological inputs, and another one in MSC regarding biological understanding, that refer to 2 aspects that we're contemplating within this research area. One is estimates of connectivity with Western Pacific waters, and you'll see that there's actually 2 research areas in which we're contemplating this type of studies. And the second one is estimates of movement between biological regions. This is quite broad, but this is really fits well with our current efforts and past efforts on looking at movement and distribution. The 2 projects that address these 2 research priorities are actually highlighted here. The first one is larval and early juvenile dispersal, and the second one would be called the late juvenile and adult migration, covering 2 different life stages. The first one is the one that you've heard in detail from Lori in June, and I'll just highlight or summarize some of the results that she presented. But in fact, what we aim with this studies is to better understand the contribution of spawning grounds to settlement grounds, and in particular to look at the connectivity of different ocean basins, the Bering Sea and the Gulf of Alaska. We're also looking at how the environment may actually change that connectivity, and these are studies that are being conducted in collaboration with the Alaska Fisheries Science Center in Seattle, NOAA, the ECO-FOSI group, and we're also looking at the dispersal of young fish. So we're following up year classes over the first 5-6 years of life. Some of the data that you saw from Lori last year, in fact, represents the modeling efforts of larval dispersal trajectories of larvae that are spawned in several locations throughout the distribution range of the species, at least on this side of the Pacific. And you can actually see here that some of those larval or model larval trajectories, in fact, fit very well with that connectivity between the east and the western side of the Pacific. In fact, there's potential spawning areas that can contribute to larvae that could easily reach the Russian coast. And this is explained in much more detail in a publication that we're actually preparing as we speak for publication. This is followed up by the use of Ray's space-time model to look at how, once settled, how those larvae will, or juveniles better, would actually move out of the nursery areas, in particular in the Bristol Bay area. So here you see in fish that are, and Lori, correct me if I butcher some of your work, here we see actually fish moving out in the subsequent year and representing that sort of counter migration that fish at later stages undergo. This is some of the data that Lori suggested or showed in June, I'm sorry. And this is related to the model contribution of fish that are actually born in the Gulf of Alaska into the Bering Sea. And here you can see how 5 different spawning areas were modeled in terms of larval movement from those spawning areas. And just to highlight, for instance, that spawning area 1, which is the only one in the Bering Sea, in this canyons here, almost the entirety of those larvae that are spawned in that particular area end up in the Bering Sea. But importantly, if you look at spawning area 2, which is this one here, on the Gulf of Alaska side, a significant amount of those larvae actually end up in the Bering Sea, approximately 50%. If you look at another spawning area number 3, which is the one that would be just south of Kodiak Island, approximately between 17 and 20% of those larvae will end up in the Bering Sea, according to the model, obviously.
Okay, those are predictions based on the model. They're not based on tag returns.
No, they're absolutely, exactly. They're just based on model predictions. Yeah. So the potential contribution and the connectivity between the 2 ocean basins is expected to be substantial. And this, as I said, is being reflected in a manuscript that is currently in preparation that can be shared with the SRB once we have a final version that is ready to be submitted for publication. Hopefully within the next couple of months.
Just quickly, sorry, Giuseppe. I don't know which one you're following, Mark, but the version that's online seems to be different to this one. I don't know if somebody could quickly flick it to Mark. The version of the presentation is.
The version of the presentation is slightly different from the one. Yeah, the PowerPoint is the same.
This one's slide 10 on the website version.
I think I'm okay, because Joseph.
Look at the PowerPoint presentation, not the PDF.
I don't think we have access to that so much. But
all right, we'll just update it. But apologies for that.
Since I missed the ontogenetic slide in the MSC talk, and I was wondering if you guys talked about the loss, the arrow that pointed out to the middle of the Gulf and said loss, and I wonder if that feeds into this anywhere. Did that come up?
No, we didn't model mortality at all.
Right, but I was just curious on that. Was there any kinetic energy type thing?
Yeah,
or,
so we did actually see that in the Gulf,
something?
and we just kind of noticed that just lately, so we haven't actually discussed that too much. But definitely in some years, the eddies, especially in the Eastern Gulf, are I mean, they look like they're just transporting larvae, way offshore, and so those larvae aren't going to have a chance to settle. But we haven't really kind of looked at that deeply yet.
Sorry, I'm updating the PDF file now. Mark, I'm not sure if you're actually looking at the screen on the webinar or you're actually looking at the PDF.
I've been looking at the screen on the webinar, but also having the PDF on my iPad.
They won't get it in time, just set, because it has to be sent to publishing and published. So just keep going for now.
Okay. The second project that is related to migration and distribution is our continuing work on late juvenile and adult dispersal First, through wire tagging. Since 2015, we've been wire tagging all the under 32 fish. We've tagged a little over 10,000 fish since 2015, and we've received to date 110 recoveries. And this map that shows the fish stations as well as the NIMS trawl stations from which we tag also from the Bering Sea, you can actually see those red lines representing the site of release and the site of recovery. And you can see that some of those actual recoveries took place hundreds of miles away from the site of release. So the movement patterns are quite significant.
We've also had 2 this year that crossed from the Bering Sea into the Gulf that have just come in.
Yeah.
One was all the way
Yeah.
down deep into 3A.
Right. Yeah, those have not been yet incorporated. Those are incorporated in the 110 recoveries, but the map has not been updated yet.
So these releases aren't jittered at all. So there could be a lot of releases at one station.
Yes, there are a number of releases at each station. Yeah.
But not necessarily the same number in each.
Right.
It's roughly 50% of the halibut caught at that station are tagged if we have a sampler on board. That's how we, yeah, so whatever that number is.
Yeah, we usually tag approximately close to 2,000 fish.
Yeah,
in our-
depending, so in the Gulf, in
in
a
our
Gulf
fish.
year, it'll be more. In the Aleutian year, it's less because we catch fewer halibut.
But it's from set line survey too, right?
Yes.
This one does include set line survey as well, yeah. I was talking about NIMS trawl here.
Oh,
Yeah, set line survey plus.
Set line survey is not 50%. I'm not sure what the percentage is there. And they didn't do it this year at all, I don't think.
It depends there on the otolith sampling rate because we don't get good recoveries on fish without the otolith.
by wire tagging, you mean coded wire tagging?
Yes.
Bit tag?
No,
No, what?
No.
just circular tag.
Spaghetti wire or perpendicular tag, twist.
Oh, so it's visible, it's not,
Yeah.
doesn't need a one.
But the recoveries are largely commercial recoveries, right?
I think so, yeah.
And that's why our rates for fish that have been tagged in the Bering Sea are still low because a lot of those fish haven't even gotten old enough to get recovered yet.
Do you get, so
Yeah,
do you
but-
get any from the trawler, from the trawl fishery,
Trawl bycatch, yeah.
the Bering Sea?
I don't think we've gotten any recoveries from the Bering Sea trawl fishery.
Yeah, I wonder if they're just going too fast with the deck sorting.
Well, it seems like it'd be more potentially.
I mean, you would think,
Well, it's not a done deal that they would necessarily report them either.
right?
It should cool prices.
Yeah, the tagging.
Yeah, I mean, that means like another dead fish.
In the 90s on the trawl.
Depends on who you talk to, how cool that is.
It might be worthwhile thinking about incentives for,
This, to be clear, this project was not designed to estimate quantitative rates among areas, but to establish which pathways of exchange are active. We were under no misconceptions that we would have a sample size large enough to estimate specific rates between areas for this project.
sure. Still seems like
It's like all pathways are
having the
possible.
potential to have recoveries from the trawl fishery would be good. Either way.
But you do get growth too.
Potentially.
Yeah, all halibut in the trawl, from the trawl survey are measured.
Yeah, all halibut caught, yeah.
So this is an ongoing effort, again, just mostly to look at dispersal pathways. This is obviously related to studies that we're conducting, and in fact, Tim just conducted this summer, electronic tagging of both under 32 and over 32 fish using satellite tags. And this was a project, maybe Tim, very briefly, you can
Yeah,
explain
sure.
what the project was.
Norton Sound Economic Development Corporation is very interested in the movement of cod and halibut into that region. They've seen a real increase in both of those resources, mostly cod, but halibut following upon them. So they funded about half of the satellite tagging this summer, and the vessels, and then we put in a bunch of tags. We had 50 some odd tags total. I don't believe we got them all out. We tagged 24 fish in Norton Sound, and 5 were tagged off the North Bering Sea Trawl Survey, again, both O32 and U32. In Norton Sound, we know the sex of those from ultrasound. In the other areas, we have fin clips, and then they had a collaborative project with the local fleet in Savunga. I know they got at least 5 tags out in Savunga. It may be more. We're gonna have a conference call tomorrow to see how many tags completely got out and what the size distribution was. And Norton Sound Economic Development Corporation intends to continue satellite tagging next year and probably the year after, as long as their board supports more funding.
When are those stats expected to report?
3 different sets, mid-January next summer, and then some of them were set for 2-year programming. So we put some tags out with 2-year programming last year as well. We obviously haven't gotten to that point yet, so
And
we'll see how
one of the
2-year
objectives of
programming
the study is also to look to see whether some of those fish were actually going into.
Yeah, and we had some really interesting discussions with the fleet that suggested that there are 2 different sets of fish demographically. They look different and arrive at different times, that the Norton Sound fish arrive much earlier than the fish in Savunga and on the northern shelf, and look different, or different colors and different sort of fatnesses. And so we have a hypothesis that they may be migrating in different pathways, that the Norton Sound fish may be coming south along Savunga and the others north over the top of Savunga, because they apparently arrive at Savunga first and then up here. And if so, these are quite likely coming from Russia, because the Russian border is really close, and we're moving back across that border line. So that's one of the most interesting questions, as to what extent will we see connectivity between Russian and US waters for some components of those tagged fish.
Thanks.
What's the 5524?
Sample size that I know of, like I said, the
Number of tags.
the 5+ may be bigger, but that's the number of satellite tags that were put out, the number of fish that were tagged.
Is that it up to about 56?
No, 56 is the number of tags we bought.
24 is not.
Yeah, that's why you've got a 5.
Plus the-
That's why you've got a 5+,
plus.
but I guarantee you they
Plus the
didn't
plus
put out
plus.
16 that I don't know about, so that total sample size is gonna be
Still
smaller.
deploying tags.
Yeah, it's gonna be in the 40s
Oh, that's it.
probably. Maybe in the 30s.
So these are, again, these are satellite tags for
Yeah,
adults.
satellite pop-up tags.
The last project is one that you've heard of before. This is the use, the potential use of natural markings in order to track fish. There are a number of questions that still need to be resolved, that we're now in the process of collecting images of tails and looking at potential recoveries. In fact, to date, we've photographed tails from 882 individuals, and we've received so far 7 tags with the corresponding images. So hopefully once we have enough retrieve images in our database, then we can start looking at whether we can actually match them or not. Again, there's a number of questions that we still need to answer, whether those markings are permanent on the tails or not, but this will lead to possibly some interesting information down the line.
Looks for whales.
Related to, again, the connectivity between the east and the western Pacific waters, and in our search to learn more about that potential connectivity, we've started efforts to establish collaboration with Russian scientists, and that started at the IPHC meeting in 2018 in Yokohama, where we established some initial contacts with Russian scientists, and then we're continuing this again in this year's IPHC meeting that will be held in Victoria less than a month from now. And along those efforts, we're actually organizing a Pacific Halibut workshop in which there's Russian participation, and we hope to attract some Russian participants to the workshop. Incidentally, this workshop is we participate in a number of presentations, and it will be a good opportunity to showcase our activities in an international conference. So as deliverables, we have now applied the space-time model. We've conducted detection modeling in collaboration with NOAA, and we have this manuscript in preparation that I mentioned before. Moving on to the second research area, and we're slightly behind schedule. I'd like to just highlight some of the research priorities that relate to reproduction, both stemming from the assessment side, one on data collection and processing related to the sex ratio you see in the top, and then the one in the bottom related to biological inputs, which is the one in relation to maturity and maturity scheduling. So the two projects that we have are specifically oriented towards those research priorities. The first one is the identification of sex in the commercial landings, and we've already presented how we are using two SNPs to genotype males and females from the commercial landings based on DNA extracted from fin clips that are collected in the field. We completed the aged 2017 commercial samples, a little over 10,000. This went into the 2019 preliminary stock assessment, and it looks like by October 15th this year, we're going to have also the entire collection of 2018 commercial samples, again, a little over 10,000 fish that will be going into the final stock assessment for 2019. The second project is the full characterization of the annual reproductive cycle to improve current estimates of maturity. Our objective here is to revise maturity estimates for male and female Pacific halibut, and with that, we need to understand what are the processes that both male and female go through in order to go into the spawning population. So what we did was we collected samples on a monthly basis from 30 males and 30 females, starting in September 2017 and ending in August of 2018 in one particular area in the central Gulf of Alaska, in the Portlock area, as indicated in that square on the right-hand side. And those samples are intended to provide histological assessment of gonadal development. The histology is completed. We also took blood samples to investigate the levels of reproductive hormones in the blood, other reproductive markers and parameters, and importantly, to compare the scoring criteria based on microscopic observations in the field with microscopic observations. What we expect to produce from these studies is an accurate staging of the reproductive status, to update maturity and age estimates, and to provide estimates of skip spawning. So what we're doing is in fact looking at how maturity has been staged so far by our sea samplers. They classify the maturity based on visual observations of the gonads. There's 4 stages that they classify females on: immature, maturing, ripe, and resting, 1 to 4, and those are recorded in the field. And what we want is actually compare those maturity stages through microscopic or visual assessment with the microscopic or histological assessment, in which this is based on the histology of the ovary, looking at sections, classifying oocyte stages, and then producing a maturity stage. And eventually we'll be able to compare maturity ogives from macroscopic versus microscopic staging, and also revise the maturity estimates.
Any of the measures that you're taking could be done non-destructively, so you could just sample an individual without having it dead? Like any of the blood work or anything like that?
Yeah, the blood work is not invasive. We have not explored the possibility, for instance, of taking ovarian biopsies through cannulation. That is a possibility, but we have not tested that in the field. Yeah.
It's still difficult to get the macroscopic staging then, isn't it?
Yeah, the macroscopic, unless you do
taking a plug.
But there are hormone levels in the blood that you might be able to correlate with some of the,
Yeah,
some of the gross anatomy that you're taking in the histology.
Yeah, potentially we could also use ultrasound to not only sex, but also evaluate the size of the gonad and maturity status grossly, looking at those images. The results that we've got so far, and these are all preliminary and they're not complete. We have now the progression, the annual progression of the macroscopic maturity stages. You've seen this, and this was in the report, in which you can see that from June, July is when you start seeing the appearance of maturing females based on just visual observations of the gonads, and ripe, which would mean spawning, only in January and February. This basically coincides with what we expect the active spawning season to be. What we want is to refine this and really make sure that we're actually considering a maturing female as what it is. It's worth noting that the maturity that is being used in stock assessment is derived from samples that were collected in the Fisheries Independent Setline Survey, and those samples are only collected between June and September. The information that goes into stock assessment is in fact immature versus mature, and so anything that is stages 2, 3, 4 is considered mature and goes into the estimates of the spawning biomass. Only the samples that are labeled as 1, immature, those are considered obviously immature. So this is something that we'll be refining with the microscopic maturity staging. So the first thing that we had to do was to really classify the oocyte stages. And so we have now classified 9 different stages throughout development, from the basically very mature oocytes, early pernucleolus, to hydrated pre-ovulatory follicles, so we know what to look for. And we've measured the diameter, so not only we know what they look like, but how big they should be in order to be that particular stage. And what we've done is to start looking at the progression of the different oocyte stages during the calendar year. So this is, it's not completed, it's just to give you an idea of what we will end up with is a proportion of different oocyte stages within every particular month. And hopefully what we'll do is, in fact, derive criteria to classify fish as immature or mature. One possibility, for instance, and this is not going to be able to be done until we have the entire annual progression of oocyte stages, is classify fish as immature. For instance, oocyte stages, imagine that we just consider oocyte stages 1 to 5 as an immature animal, and an animal that has oocyte stages 6 to 9 would be considered a mature animal. Those are the kind of the criteria that we'll have to classify mature versus an immature female. Okay? And we would be able to derive something like that, for instance, if we use those stages to classify an immature versus a mature female. We could end up with a certain proportion, and this data is not final, is preliminary, and will likely change after revision. But this is just an idea of how we may end up classifying fish as mature or immature with the oocyte staging.
Do you think this might, I think historically most of your data has been macroscopic, isn't it? Staging, the historical data set.
Yeah, all of it, I think.
Yeah, well, you thinking that with these different classifications you can go back and reclassify some of those historically, or is this about going forward and being better at predicting changes?
I think it's the latter. It's moving forward.
Okay.
It's refining the criteria for macroscopic classification. Maybe we need more stages, or maybe we need less stages. It's to find.
You don't think you can go back retrospectively to?
No, not just with stages 1 to 4. If we had more evidence, that images of those.
But I
particular
guess you could
zones,
potentially look at how good you are at staging them.
we could, yeah, but I think it's mostly for going forward.
The past data, those fish were sexy and their gonads were thrown overboard.
Okay.
And so we have no samples, but you could easily do the exact same procedure on survey that we do now, then have them collect samples and compare the two results. So like you said, see how good you're doing it.
No, it's just that in ICES, people recently looked at this again and compared macro and microscopic, and they decided that you can't actually tell anything from macroscopic except right at the time of spawning.
Right.
And therefore they've gone back and said that's all we're recording now.
Yeah.
But actually it's coming back to bite them in the behind now, because you're seeing temporal changes in the development of the gonads, which just, you no longer can do anything with.
So this is just an example of how things are progressing. Obviously, we do have the ages, but the age is not incorporated here. That is another parameter that will be considered. So we're going to be looking at maturity stage by age, but that has not been done yet. So this is a work in progress. So in summary, what we've done is just look at a snapshot of reproductive development in one particular area. We don't have information on spatial differences in maturity. What we've done is, in fact, go and collect samples within the time where we conduct our fisheries independent sightline survey. Those samples that we've looked at now span the whole calendar year, but the actual collection that will be done subsequently will have to be done within those 4 months, unless we charter specific gonad collections outside of the service season, which is quite prohibitive for that matter.
Joseph, are these all same size fish? What sizes of fish are these?
These are fish that, well, the ones that we're going to have the data for are fish that the males are larger than 70 centimeters and the females are larger than 90 centimeters. That was a criteria for size selection throughout the entire calendar year.
And the 30% in December is just an artifact of the sample size, is it?
I'm sorry?
The 30% immature, it's not a recruitment in December, I think it is.
Here?
Yeah. Just seems that's not really a trend or anything. That's just.
Well, that is something that we'll find out what that represents exactly when we do the histology of those same fish. So we have, for the same fish, we'll obviously have the microscopic staging. What I'm interested in looking at is what are we classifying as immature? Could there be the possibility that the proportion of those fish are actually spent? That those fish are either completely immature or skip spawning, or in fact, the two categories are mislabeled.
Treasure or whatever.
So we have the histology for those animals, and it'll be very interesting to see why there's such a relatively high proportion. Third.
Yeah, it could be very real. It could be a seasonal spatial effect that where they chose to fish, all of the adults or a larger proportion of adults had moved offshore to spawn and the juveniles were left behind.
Yeah.
And you would see that in a winter month.
Right. So we'll have more information. For instance, we'll have age information to see if those fish are actually young fish or some are old, and we can actually look at the ovary and we can test whether those fish are treated or they've skipped spawning.
Or just late
and
maturing.
And there's evidence for previous spawning events. So we'll have a lot more information on those fish. That's why I think it's important just to use the microscopic staging to refine and improve that maturity classification. So what we've done is just the collection in one particular area. What we actually have is 3 years of collection in June in the same spot. So we have a little snapshot of whether there's any temporal variability. So we have the samples from 2018 that have been analyzed, but we did also collect samples in 2017 and again now in 2019 that have not been analyzed yet. So for at least for one location, one geographic location, we may have 3 consecutive years to look at whether there's any temporal change. So
how can you generalize that one location to spawning across all latitudes and all longitudes? I mean, there's a huge, I mean, where, you know, Piera had all the spawning locations. I mean, that's a very large range. You're sampling one area right here.
Right.
If you sampled, you know, in a different latitude and a different longitude, would you expect to see that same profile?
well, that's the next thing. It's the research proposal that is coming up is really to look at spatial analysis of maturity. What was not possible was to do what we did in Portlock throughout an entire calendar year throughout. This was a tremendous project with an incredible number of samples, and it's going to take us quite a while to analyze. So what we're trying to find out with this study is actually what would be the ideal window of time to sample those fish within the time of our survey, which is really when we can actually collect samples relatively easily. Okay, and the proposal is that probably July or August would probably be a good enough time to start looking at sample collection. If you look at, not so much here because this is macroscopic and you have to take this information with a grain of salt. But if you look at the GSI, that's really between August, around August when you start seeing some differences. And that's, again, that's just going at weight relative to the round weight. That doesn't tell us much. But when we look at the histology, we'll probably find out that in August, we'll see those females that will be progressing and we'll be able to identify those. But again, this is without having all the data available.
It seems like one of your best signals is the GSI,
Right.
and that's
Well, so far,
pretty easy,
but
right?
that's fairly easy, but it is also fairly inexact because you're only looking at going at weight, and that doesn't really tell you much about the maturity stage. We'll see. We'll see how the GSI compares. The GSI is just a matter of weight. I mean that, it could be swollen, it could be hydrated without maturity.
Is it weight or is it
But if
weight?
it's low,
Counted
it's
for by
unlikely to
body
be
size?
I'm sorry?
Is it a portion of body size? I mean, is it relative to the total body size?
Right.
And to speak to your earlier comment, even GSI, analysis of the migration timing from archival text suggests that the migration time varies spatially, latitudinally, and by basin. And so I would expect that curve to also shift, that the migration timing would be related to gonatosomatic index and time of maturation. So I do think that we expect maybe the form of the curve to be consistent from place to place, but its position during the season to vary.
I mean, it's a valuable measure, but I think it's worth noting that it's a gross measure of gonadal growth and development.
Very quickly, Kim, but just to clarify your earlier question about the spatial element, but I guess it's worthwhile waiting to see if that indication between the link between the microscopic and the macroscopic, if you end up with a conclusion you can do it macroscopically, then I don't see that for the spatial maturity element that there is any need to go to the microscopic.
Right, the other question is can you do it within the context of the fisheries independent survey timing too, right? Because if you're out of that window of predictability, then you're really not going to be able to generalize the results.
Yeah, and I think if that ends up being a suitable time to look at maturity, then my suggestion would be to do a histology alone with samples collected at a certain period of time.
What's the extent of the GSI data now from the survey? Is it routinely collected for any or
No,
any?
no. No, it's not routinely collected. No.
Fine scale.
Yeah, we actually, when we were collecting, we had 2 scales with 2 different ranges.
Okay, I don't want to cut this off, but people are getting restless for a break.
I do have one comment that, before he moves on to this, that I think we can talk about it at the break even, but have we linked this to space-time modeling at all? Because it seems like some consideration of all the benefits we see with space-time modeling could be leveraged here. So anyway.
Which I think you're doing, right? Is that what you're planning to do?
Those
No, it's
stations,
space-time.
I'm betting that they're not gonna get rid of them.
I thought I saw some space.
Just to clarify, you mean if we end up with a sampling design that's obviously not complete, comprehensive, we could use geostatistical method to interpolate across the population?
Yeah, I mean, it may be worthwhile to evaluate sampling a broader area, but maybe less intensely. I don't have a good grasp of the cost of the sampling effort.
Most of the cost is just getting out there, right, with the boat. If the boat's already out there because they're taking the samples anyway, it's just the cost of these assays.
Yeah, and they're scoring for maturity anyway.
With the caveat that we only have 2 to 3 individuals on the boat yet, so that are essentially fully tasked.
So at some point you drop from the vessels being able to fish 3 stations a day to 2 stations a day, and all of a sudden you get vessel costs.
Yeah. I mean,
Is there the value of the fish go down with the processing for this?
I mean, is it possible to get fish outside of the size ranges? So you could look at maturities, at younger fish, right? Because you're getting the otoliths of these things as well, right? So you got age with all these guys, and you got sex, obviously. But
Yeah, in survey you get all the sizes from about 50 centimeters up. Selectivity goes down to low sizes, but
yeah,
those thresholds were set for winter charter to try to get as much data as possible over the charter window. But yeah, for survey you're getting all fish of all sizes.
Okay, so let's take until 4 minutes.
Okay, see you then.
Thanks, Mark.
Which one is it? The one before?
No.
City.
He saw that he was.
John, what is the travel training called, the hot sauce training that